pharmaceutical sciences. SAR is guiding 6 PhD research scholars in the field of pharmacy. SAR is a life member of several professional bodies like IPA, IPGA, APP, and AAPH. SAR has published 4 book chapters of books with the international publishers. SAR has published 30 research papers in reputed national and international journals. And finally, SAR is a founder of an organization called MIBO Group, so which is a platform for all the pharmacy students as well as the pharmacy professionals to learn the different research programs, as well as this is very helpful for the designing several creative projects for the benefit of the pharmacy students as well as pharmacy professionals. So with the brief introduction, I'm inviting Dr. Jason Koteswar Rao sir to deliver his speech. Welcome you, sir.
Yeah, thank you very much, Dr. Krishna.
Thank you, sir.
Is my voice audible?
Yes, sir. So you're audible, sir.
Yeah. Shall I go ahead with my presentation?
Yes, sir. Sure, sir. Sure, sir.
Yeah. Thank you very much. First of all, I am thankful to the organizing committee members for this AICTE sponsored STTP being organized by Annamacharya College of Pharmacy, Rajampet, Andhra Pradesh. So it's my privilege to be a part of this program, and we have good friends over there like Dr. Dr. Suru Prakash, Dr. Mavi, and I am thankful to all of them for remembering me and making me a part of this event. And I'm also thankful to Principal Dr. Swanalata Madam, and all other faculty members who are coordinating for the success of this program. So I hope this will be a grand success because I am observing your efforts in conducting this event since yesterday. Okay, so coming to our today's topic, without further delay, I will go ahead with the presentation. So the topic selection is related to statistical quality control in control strategy. So here I want to say one point regarding the selection of topic. So initially we thought it as an offline face-to-face STTP. So in that perspective, I thought of delivering a talk on this important topic, SQC in control strategy. So such that we can have some interactions, we can have some demonstrations, workshop like that thing within that 1 or 1.5 hour topic. But unfortunately, because of pandemic, we came online. Even then, I tried to develop some practical case studies. So in that angle, I hope I can deliver the topic in a better manner, even though it is a e-platform. Let me go to the presentation. So the topic for today's discussion is statistical quality control in control strategy. So myself, Dr. Koteswar, as told, working as Vice Principal and Professor at KL College of Pharmacy, KL University. I am thankful to our university for permitting me to deliver a small talk on this selected topic. So the session outcomes, at the end of this session, the participants are supposed to have an idea about the importance of SQC, statistical quality control, and what are the terminologies or different parameters that are related to SQC. And they will have a brief idea about what does variable charts means, what does attribute charts means, and finally they are supposed to have a practical application. So my main perspective is how to use these charts rather than just going through the theory part. I am focusing more on the practical application. If you can follow the session properly. So I believe that at the end of the session, the participants will be able to apply these charts practically, even when they get job in any industry or even during academic activities also they can apply this. So for that, I have divided the contents into these brief subheadings, like a small introduction will be discussed about SQC, and different control charts and terminologies will be discussed. And under variable charts, we will be talking about X bar, R chart, and S chart. Under attribute charts, we will talk about T chart, NP chart, and C chart. And further, following to that, we will be talking about the calculations, how to do the calculations. And of course, there are some softwares like Minitab and some other statistical softwares. But I will be allowing you to handle through Excel sheet, case by case. I will explain through the Excel sheet. And then another one is applications of SQC. Finally, at the end of the session, we will be briefly talking about what are the advantages or applications of following this SQC in industry or regular life, and a brief conclusion followed by some references. This is how I plan. So at this moment, I would like to remember the person who is behind the introduction of this SQC, Walter Andrew Shewhart. That's why these are also called as the Shewhart charts. So he's a great physicist and also statistician. So by remembering him, let us move forward. So here, what is this SQC means? Already we are aware of what is quality control or what is quality. It's nothing but any product or any service, if it is conforming with the prescribed standards, we can say that product is as per quality, or we can say like it is having fitness for the intended purpose. For what purpose we are going to use that? If it is able to serve that purpose, we can say the product or the service is of good quality. And in order to have that quality, we should maintain some control strategies. So in order to control the quality, we are implementing statistics. So if you implement some statistical methods, if you use some statistical methods for monitoring and control of the quality, in order to take some meaningful decisions based on some experimental evidence, statistics itself is a factor of evidence. So based on that, if you can try to control the quality, then we can call it as statistical quality control. And there are so many methods under this SQC. The selection of an appropriate method, which method is suitable for which criteria, it depends on what is the type of measurement you are doing, whether it is a continuous measurement or discrete measurement, what is the sampling technique you are following, and which DOE you are following, and what is the type of sample distribution, like we all are familiar, like normal or binomial or Poisson's, like that. So all these factors will influence the selection of a particular method in order to control the any control strategy. So the process, the control strategy, general process, maybe in yesterday's talk or in the coming talks, our speakers will be talking about this. We will be continuing a process. Assume a tablet manufacturing process is going on. In the process, we will be collecting some samples. That means some tablets will be collected at 8 a.m., 9 a.m., 10 a.m. like that, and they will be analyzed as per the expected parameter, maybe weight variation or hardness. Let it be some parameter you are verifying, like its diameter or thickness, something. And we will try to identify, are there any variations? If no variations are there, means good, the process is going well. And again, you will be randomly checking the same continuity after certain time. Assume that there are some variations, then it's the job of the production department and the particular assigned part of people in order to identify what is the cause for that variation. So there are different types of causes we will see in the next slide. So once you are able to identify the cause, then you need to work on rectifying that problem. Whatever the problem it is, for example, a punch has been damaged in a punching machine, then you need to replace it or you need to repair that particular machine like that. So for what? In order to get the quality back or in order to improve the existing food quality to a level of expected quality. Then again, you have to continue the process. Again, the production process will be continued. So once it is continued, again the cycle repeats. Again, collect the sample, again analyze it, identify variation. If no variation, well and good. If any variation is observed, try to get the reason for that variation. Solve that problem. This is what called as a control strategy or a sequence of steps involved in the handling of control of quality. Now, what are the different causes of these variations? Okay, there are some deviations in the product quality. That means weight may be deviated or the percentage SA may be deviated. Something has been deviated. So there are two reasons, expected reasons are two for that particular variation. That is, first one is called chance cause or random cause, and another one is called as assignable cause. Okay, let us see what is this chance cause or random cause means. So these are inevitable. These are inevitable. We are unable to remove them. They are natural and inherent. They exist in the process. They are very, very minute reasons. They are very minute causes which we are unable to remove them. But because of that, a small variation may be observed in the process. However, they may not cause damage to the quality. Such type of variations are called as chance variations, and the reasons for such causes are called as chance causes or random causes. For example, a slight change in the temperature of your working environment or pH, or small change in the operational time or service time, like those things. These are inevitable. So there won't be any issue with these chance causes or random causes. We can say the quality is under control. But if you talk about the assignable causes, if you observe a change in the quality or a change in the parameter, and they are called as a big variations, there will be some cause, a reasonable cause. For example, there is some fault in the machine, or the workmen or the people who is operating that machine may be inefficient or non-skilled, or some part of the instrument may have broken, or it may be a new operation. You are trying exactly a new operation. It's not the thing that is expected to be done. So like that, if there is some reason, the raw material whatever you use it is having some poor quality. So if the raw material itself is of poor quality, how we can expect a good quality in the final product? So there is a reason, because of the selection of poor quality raw material, the final quality of the finished product is varying. So that is because of some assignable cause. We can assign a cause, a specific cause for that variation. And then what is our job means, we need to detect that cause, what is that cause, and we need to correct that one. So this is a step involved in the control strategy, the sequence of steps, whatever we have discussed earlier. There we have to understand whether the variation is because of chance cause or because of assignable cause. If it is because of chance cause, it's okay, there is no need to worry, we can relax. But if it is a big variation and it is expected to have some assignable cause, a specific cause, then we need to identify it and we need to correct it, and after correction again we need to verify whether the quality has been improved or not. This is the difference between chance cause and assignable cause. I hope you guys are following. And the next thing is, so these SQC, this statistical quality control, will help the people who are following this one in order to understand what is the magnitude of the chance cause or chance variation observed, and is it an assignable cause and showing some assignable variation that can be caught, that can be catched by following this SQC strategy. So what is our main concept or main criteria means, in order to select this SQC means, our target is to eliminate the assignable variations which are because of assignable causes. Then only we are able to bring the process into our control. This can be possible by SQC, by following statistical quality control. So a product or a process is said to be under control if the variation is just because of chance cause only, and there should be an absence of assignable variation. So there should not be any variation because of assignable cause. However, there may be chance variations. Then only we can say the process is under control. This is what we need to understand, and this is possible by following the SQC, statistical quality control. So under this SQC, we are going to use charts called as quality control charts or simply control charts in order to identify the variations and in order to know whether the process is going out of control or is it under control. Now let us go to the next part of the discussion. So here, whenever we are using control charts, we should be aware of some terminologies. So what are those terminologies means? There will be a word called as central line. So this is the middle line. All these lines, central line, upper control line, or limit, lower control limit, all are horizontal lines only. Central line will be generally drawn as a dark line, whereas upper control limit and lower control limit are drawn as dotted lines. Then what are these things means? Central line is like the expected mean value or the average value or the prescribed standard value which is expected from the sample data. And whereas upper control limit is the highest limit that is permitted, or it is the limit of tolerance. Above that, the product quality should not go out. And again, lower control limits, it should not go below this limit. So the product, if it goes below this limit in a respective parameter, let it be weight or let it be some hardness or weight, or I can say diameter, something. So we are giving some lower control limit and upper control limit and an expected central limit or central line. So these three will be drawn on a graph sheet. All these lines are parallel to the x-axis line, and they are named as central line, upper control limit, and lower control limit. And another things are like, if all the sample data, all the samples are showing the values within these upper control limit and lower control limit, then the process is said to be in control or under control. So if the data points are moving out of this range, like they are moving above the upper control limit, or if they move below the lower control limit, then we call it as the process is going out of control, and we need to stop the process and we need to check where that deviation happened. Is it because of which assignable reason? So if it is going out of control means there is an assignable reason. If it is just scattering but it is not going out of the limits means we may assign it because of chance cause. But if it is crossing the upper control limit or lower control limit, then surely there is a specific reason, specific cause, and we need to assign some reason. So that reason has to be identified by stopping the process or during the process, and we need to solve that problem. And again, the process has to be continued. Again, the whole cycle of collecting the sample, analyzing the data has to be done. So until the process comes into control or under control. So let me show you one rough diagram or chart. So assume this is a graph sheet with y-axis and x-axis. On x-axis, assume there are different sample numbers like 8-hour sample, 9-hour sample, 10-hour sample, or sample number 1, 2, 3, 4, 5, something like that. You can give or day 1, day 2, day 3, or January, February, March, or year 2018, 2019, something. So any number you can take on x-axis. Whereas on y-axis, it may be some assay, it may be weight variation, or it may be some diameter, some. If it is not only in pharmacy, these charts are applicable in any department or any industry. So it may be sales of particular bike or any product, something like that. So here, as I told, this mean, the center line, which is in dark color, black, dark, this is called central line. And this dotted lines drawn above the central line at certain value is called as upper control limit. I have kept some upper control limit. So mean value may be 90% SA, or upper limit is 94 or something weight. Let it be some weight or something. And lower control limit, as per this chart, it is showing 86. So the products, whatever the sample you have taken at 8 a.m., so it is within this range. This one has just touched the lower control limit, this third sample like that. But if you consider this some 20th sample are taken at so and so time or so and so date, or let it be at certain point. So it has crossed the lower control limit. It came below the lower control limit value. Then I can say this is out of control. So after assume that it is a tablet weight or something, and after doing punching for a period of 1 hour, after 1 hour you got a sample whose value is going below the lower limit weight 86 mg, below that it went. So it indicates the punching machine is going to do something mistake, it has something happened, or it may be going worst in depth again. So in such a case, the production department has to stop the process here, and they need to verify why it happened, and again assume that it was corrected, and again it was solved something. Again after certain time, maybe in the afternoon shift, morning shift was done by some Keshav, in the afternoon shift it has been taken by some other Vamsi. So because of poor knowledge of that operator, assume again mistake happened. So here the mistake is because of some loose fitting of the punch, or here the reason may be assignable reason is because of the poor knowledge of the operating person. Hence again you need to change that person. So for each failure or for each out of control factor or symbol, there will be an assignable reason. It may be a same assignable reason or different assignable reason. We need to correct that, and this chart is helping us where the process is going out of control. As and when it is going out of control, you need to stop the process, or you need to have a revision, and you need to solve that problem. This is how control chart is helping to the manufacturing people during the process control. Now, in the control charts, there are different types. Now we came to know there are some charts which are having some lines, and the values are plotted on the graph by using some particular measurement. It may be any measurement like that. So these charts are further divided into two types. They are called as variable charts or attribute charts. Other way, we can also call them as control charts for variables, control charts for attributes. Now let me explain again what is this difference. So earlier we discussed certain terminologies like control, central limit, upper control limit, LCL, lower control limit, and we have seen in control means what, out of control means what. Now we are going into the application level, which I am saying there are multiple charts. In today's session, we are going to discuss some of the important major charts. So those charts are further divided into variable charts and attribute charts. Then what are these two terminologies means? Variable charts means whenever you are dealing with a product, that means some element that you are going to determine whether it is in control or out of the control by a certain process like manufacturing or filling the bottles of syrup, something you are doing. So if the values are in continuous mode of distribution, and if they are measurable like 100 ml, 50 ml is filled, 49 ml is filled. If it is a tablet weight, you can measure 100 mg, 1 or 2 mg, 99 mg. If it is some height, you can say 3 centimeters, 3.5 centimeters, 5 feet, like that. So like that, if the characteristic is measurable, then these charts are applicable, and those charts are called as control charts for variables. These are measurable. You need to consider that point. Then what is this attribute charts means? These are non-measurable. However, these are countable. You are able to just count, but you are unable to measure. So these are generally in the category of go or no go situation, whether it is yes or no, whether it is good or bad, but you don't say whether it is 90% good or 80% good, 30% bad or 20%. We are unable to give some numerical values here, but you are able to count them. So there are 3 good eggs and 5 bad eggs. So like that you can define them, whether it is a defective piece or non-defective piece, but you are unable to say whether the defect is 5% defective or 10% defective. So whether it is perfect or whether it is fault, whether it is proper or defect, defective or non-defective, conformative or non-conformative. So it's like go or no go. Either you can call it as good or you can call it as bad. Such type of things we call them as attributes. So here you can say out of 100 tablets, 10 tablets are defective. Then you may express that one as percentage, or you may express that one as fractions, or even within each product. For example, you have taken one or let it be some bottle syrup. In that syrup bottle there may be number of defectives. One section is like whether the total bottle is defective, you can discard. In another section, number of defects, or no, it's not defective, number of defects in an unit. Let it be like there is one mobile phone. So in that mobile phone, speaker may not be working, Wi-Fi may not be working, or contact saving may not be. So 3 defects are there in a single mobile. So like that in a single unit, how many defects are there is one perspective, or whether that mobile is defective piece or non-defective piece. Out of 10 mobiles, 6 pieces are waste, only 4 pieces are good. So that is one way. Another one is in each mobile, how many defects are there. So we are able to count. We may not be able to give the exact measurement like variables. So this is the major difference between control charts for variables and control charts for attributes. Now let us go to the different charts that are present. Under variable charts, there are majorly 3 charts: X chart or X bar chart, which is also called as main chart. Another one is R chart, which is nothing but a range chart. And another one is S chart, standard deviation chart. Throughout my presentation, we will be going through these terminologies only. And coming to attribute charts, that means which are not measurable but can be what I can say counted, that can be possible to count. They are called as a P chart, NP chart or C chart. So these 2 charts are somewhat related. P chart means fraction defective, NP chart means number of defectives, whereas the third chart is somewhat typical. I can say like how many defects are there in a single piece, like how I told discussion under this C chart. So number of items or number of events that are taking place within a piece or within a certain time, that comes under C chart. So these are the different charts. Now here we may be very much familiar. Mean chart means it talks about the central tendency, that means average character or average value, whereas range chart talks about the dispersion, that means variation, or is from the mean value. So that is coming under this range chart. It can detect the dispersion of the particular values from the mean value. And mean chart talks about the central tendencies, whether all the samples are having similar central tendencies or not. Whereas standard deviation also talks about the dispersion or variation of the data. However, for large readings or for large number of samples, the standard deviations are good enough, whereas range charts are useful for smaller sample sizes. So we will be discussing all those things in the coming slides. So as of now, please be clear that there are 2 types of charts, and one category is variable charts, under which 3 types of charts are there, and under attribute charts we are going to discuss another 3 types of charts. We will go one by one. So what is my plan for today's session is like, we will be first talking about variable charts. We will have a practical session with Excel sheet. After that, again, attribute charts discussion is very small. Once you are good enough with variable charts, you can easily understand the attribute charts. Calculations are very simple. So here, then in the second half, I will go to attribute charts, and I will give you a small case study, how to handle the attribute charts, how to draw the charts, everything I am willing to explain practically. In that way, this theoretical PowerPoint I will try to finish as soon as possible in two halves. First half about variable charts like that. So after that, at two respective time periods, we will go into the Excel sheet and we will handle the data. Okay, before going into a particular chart, before talking about X bar chart or any chart, I want to give you few inputs. Maybe you are good enough, but still, for my convenience sake, I want to give some inputs. So here, let it be a sample number. Assume we will be filling the data in Excel sheet or in your notebook, observation book like this, a small table, for example, rough example. So here I have given one column called as sample number. In this sample number, I mentioned like 1, 2, 3, 4, something like that. Or you can mention like day 1, day 2, day 3, day 4, no issue. Or you can say like 8 a.m., 8:30 a.m., 9 a.m., 9:30 a.m., like that. For example, now our Anmachara college people are conducting sessions. They can say like session 1, session 2, session 3. So for anything, they can have some numbers, sample numbers. And these sample numbers, whatever in the present case, it is 12. So sample number is 12. Generally, we can use a symbol called as K in order to talk about the sample number. So how many samples are taken? In the present case, if anybody asks, you can say we have taken 12 samples. As what is the sample number? Symbol is K, like that you remember. Okay, at 8 a.m., let it be you have taken some tablets in order to check the weight or assay something, or let it be disintegration time in some seconds. So sample 1 means assume that we have taken at morning 8 o'clock. So you have taken 4 tablets at 8 o'clock. Assume you have taken 4 tablets at 8 a.m. So first tablet and second tablet, third tablet, fourth tablet, readings are this one. First tablet has shown disintegration in 65 seconds. The second tablet shown in 63. Third tablet on 55. Fourth tablet on 54. So at 8 a.m. sample, you have taken 4 tablets and you have done that particular evaluation test. In the present example, let it be disintegration test. And you have noted the values and units may be seconds. Let it be. So whatever these 4 tablets you have taken, this is called as sample size. This is called as sample size. So I am writing. And the symbol, remember the symbol here is N. The symbol for sample size is N. So now if anybody asks you by showing this table, what is the sample number means, you say it as, remember it as symbol K, and sample number is 12. If anybody asks what is the sample size, you understand in each time or at each time of sampling, how many units are taken, how many observations are taken, how many points or how many items are taken. Like that you can understand units, items, observations in each time of sampling. So in the first time of sampling, 4. In the second time also 4. Third time also 4. So 8 a.m., 9 a.m., 10 a.m., 11 a.m., 12 a.m. So at different time points, every time you are taking the same size of the sample, that is N. So in the present case, if anybody asks what is your sample size, please mention it as 4. So these 2 points are very important. You need to understand. So sample number is K, how many times you have taken. If anybody asks sample size, so how many units are studied in that particular sample time, that is sample size. So I am saying repeatedly means I have seen multiple people who are having a confusion in this perspective. If we don't know this one, the calculations will also be looking very confusion and we are unable to move forward. Okay, fine. So now as there are so many different charts, we came to know X bar chart, mean chart, R chart, and another one is S chart. And we are also aware of P chart and NP chart, and another one is C chart. Here it is another chart U. We are not going to discuss it. Okay, so there are so many charts. Which chart is to be selected at what condition? That is a criteria we have to understand from this flow chart. So which chart is possible, which chart has to be considered means this difference we already came to know. So based on the data, if it is a continuous data like which is measurable, then you can go for variable charts. So these are variable charts. If this is a discrete data, then we have to go for discrete data means it can be counted, but that particular variation may not be measured. So here we can call the charts applicable are attribute. See, terminologies may be varying. Earlier we mentioned it as countable, non-measurable. Now they are using discrete. Okay, acceptable. So based on this only binomial distribution is possible. Whereas in case of continuous data, here what I can say normal distribution curve is possible. In that case, variable charts are used. In discrete data, countable data only like go or no go, pass or fail, success or fail, Those things are possible by attribute charts. Okay. Within variable charts, again, is there any criteria in order to select a particular chart? Means it again talking about the subgroup size. Subgroup size is nothing but the sample size. So as I already told you, sample size means n. So in the previous example, what is n? N is equal to 4. So in this study, they have taken 4 tablets only. So for this, which charts are applicable? If that is a question, this flowchart will give you an answer. If the sample size is in between 2 to 9 or 2 to 10, so it's not like a fixed table. So sometimes you can grab multiple charts for the particular data also to get an idea. But this will help us. This will guide us to get some basic information. So if the sample size is in between 2 to 9, so the previous example fits here. Then what are the charts you are supposed to draw? Very good. X bar chart and R chart are sufficient to get an idea whether the process is in control or out of control. Assume that person has taken 12 tablets, 15 tablets, 20 tablets in each sample. So it is more than 10. If that person has taken, or you are the chemist and you have taken more than 10 tablets in each time, then it is coming under different chart. Generally charts will be in a paired pattern in variable charts. Not single chart is suitable. Generally paired charts are done. At least 2 charts will be done. So if the sample size is big, as I already told to you, if the sample size is big, standard deviation can give more information, perfect information about the dispersion. If the sample size is small, range is sufficient. That's what we have already discussed about range and standard deviation. So what is the final thing we have to understand? X chart is a common chart, whatever may be the sample. But if the sample size is less than 10, we can go for X bar chart along with jointly R chart. If the sample size is bigger one, we can go along with X bar chart. We can also go for standard deviation chart. This is what you need to consider. And if the sample is only one, every time you are taking only one sample and only that is possible. In that case, it is called as X chart as well as moving range. So we are not going to touch this one because it may create some confusion. So I will be focusing majorly on the main charts because generally we take more than one sample. So these are called as X moving range chart, individual moving range chart. So XMR or IMR charts. So with the basic knowledge of today's discussion, you can refer these things later, no issue. Now coming back to the second half, attribute charts where discrete data, only units countable data is available. In that case, so it may be considered as defects or defectives. So that means defectives means yes or no, go or no go type. Defects means in each mobile, how many defects are there? In each bottle, how many defects are there? Like this. So as already told, if number of defects are countable, we will go with C chart. If it is about fraction defective or number defective, out of 100, 10 tablets, out of 100 tablets, assume 10 tablets are having defect or defective. Then we can call that one as, if you want to count a fraction, 10 by 100 is equal to 0.1. Then in that case, we go for P chart. But if you want to count it as numbers only, 10 number, 20 number, then we call it as a NP chart. And of course, there is a small difference between P chart and NP chart based on the sample size. If the sample size is constant, that means every time you are taking 10 tablets only, like that means you can go for NP chart generally. If the sample size is somewhat varying, in that case, P chart can handle the data properly. That means in the first sample you have taken 8 tablets, in the second sample you have taken 6 tablets, and the third sample you have taken 9 tablets. So that means sample size is varying means P chart can handle, because you are going sample to sample fraction calculation. Here we are going to count the number. So this is one. As you proceed with the practice, then you will be understanding the difference of this sample size variation and constant sample. So this flow chart will give a broad idea which charts are suitable for which type of data, whether it is measurable data, non-measurable data, that means continuous or discrete type. Within the continuous, based on the sample size. Within the discrete type, based on whether fraction defectives, or you are talking about defects per unit. That means number of faults particularly present within a single unit. In that case, C chart. So this is excuse me, sorry. So like that, this flowchart will give you a broad idea. Now this is again a formulation type. Now if you see, it will be somewhat confusing. No need to worry. As I already told, if it is less than sample type 3, mean chart, average means mean chart and range chart are used. If it is more than 10, sample size I mean to say, then you can go for mean chart and standard deviation chart. These 2 points you can remember. Remaining are median charts and moving range charts, as of now, no need to worry. So we can skip this slide because you may be getting confused. So here, before going into an individual chart discussion, let me have a small what I can say, representation of our normal distribution curve. We all are very much familiar, I hope so. So regarding this normal distribution curve, which is having multiple names like bell curve or Gaussian curve, something like that. So assume there is a mean value for that particular data, whatever we have collected. So around from the general statement is like, or majority of the cases or situations fall or agree with this normal distribution curve. So most of the cases, maybe students IQ levels in a class like that. So here it is indicating like the standard deviation, as I told, it talks about the dispersion, how much far it is going away from the mean. So it may be positive side +1 standard deviation, negative side also lower type -1 standard deviation. So in that level of, so the deviation is very small. Assume that sigma value may be some 5. So 1 into 5 is equal to 5. That should be added to the mean value. And here -5. So we will have some a broader range like. So in this range, with a difference of ±1 standard deviation, within the total data, 68.26% data fits within this range of. That means assume, for example, in a class, so many students are there. Among those students, assume that you are having a mean value, their pass percentages or marks are like 80%, and the standard deviation we got from the whole data is like 5%. So 80% ±5 means what? 80 plus 5 is equal to 85. 80 minus 5 is equal to 75. So 68.26% of students out of 100 students, 68% means 68 students will have the pass percentages or the credits of 75 to 85 range, and 95% of the students will have the range of mean -2 standard deviations to the range of mean +2 standard deviations. Already we came to know standard deviation is 5 and average or mean value is 80% or 80 grades something. So 80 plus 2 into 5 is equal to 90. So almost 95% of the students will be within 90% range, and then 80 minus 2 into 5 is equal to 7. So like that, 95% of the participants or the particular students or the sample data fits into the range of mean ±2 standard deviations. And finally, if you take a range of mean ±3 standard deviations, plus side +3 sigma and the other side -3 sigma, almost 99% data, 99.73% data is said to be fitting into that range. So in that way, this normal distribution curve fits the maximum situations on all the regular situations. If not, the data may be going into the other conditions like Poisson's distributions or binomial distributions. So we are not going to touch these distributions more. Just for an idea, I am talking about this because in this control charts, scientists suggesting us to go with the ±3 standard deviations to fix the upper control limit. This is the upper control limit level, and this is the lower control limit level. So that weight variation of the tablet or disintegration rate of the tablet should not be going beyond this upper limit, and it should not go beyond this lower limit. This is like UCL and LCL, and this is central line. But we are observing this one in a vertical screen. So if it grows out of this UCL or LCL, which are nothing but equal to +3 standard deviation limits and -3 standard deviation limits, it indicates that remaining students are something typical. If they are getting less than this 65% means we need to give a special attention to those students. And if they are getting more than certain percentages means there may be some assignable reasons. They may be favored by the teachers, or they may be something extraordinary meritorious students. We need to focus them. We may call them as advanced learners. This category we may call them as very poor. We need to give more attention. We need to give more external observations or external sources for their success. So this is how, that means something different. They are not behaving normal. These are extraordinary students. These are very poor students. So they are out of this 99.73% of data. In our pharmacy perspective, we should consider them as their weight is going abnormally more than the maximum limit, or their tablet weight is going abnormally lower than the expected LCL. So this is how this normal distribution curve can be compared with our SQC, statistical quality control input. Now, If a data is like this, it indicates, assume that this bell-shaped curve, which is having a dispersion range of very small, we can say like it is having a smaller standard deviation. So all students are near to 80%. Whereas if you see the second class, another class students data, mean is 80% only, but there is a range, broad range of students from 60, 50% gaining students are also there. Like they are getting very poor marks and some are very highest scoring marks. So this is having larger standard deviation. So based on that distribution of the data, the standard deviation varies. Now I want to just show this table, no need to worry. So this is one statistical table. Whenever I say the data is obtained from statistical table, you need to consider this, what I mean to say. For example, if I say sample size is 8, let it be this first column, you can see subgroup size or sample size. So here the sample size is nothing but 8. So here 8, the sample size is 8. In that case, if I ask what is the A2 value for a sample whose size is 8, means you should say or you should identify it is 0.373. If I ask what is the B4 factor, these are some factors we are going to use in the upcoming slides. Just I want to show this table early. No need to worry, no need to buy heart. So this table we need to use in order to get certain values. So what are those values means? Let it be, if I ask B4 value for a sample of size 5, if I ask like that, it is nothing but 2.089. If I ask the B3 value, if I ask B3, sorry, B3 is my screen visible? If anybody can please see.
Sir.
Yes, sir. It is visible, sir. Visible.
Yeah, thank you. Unfortunately, I touched some point. That's why I walked it out. Okay, thank you. So if anybody asks, or if your teacher, or if I ask, say the B3 value for a sample size, that means the person is taking 5 tablets in each sample. So 5 is the sample size or subgroup size, we can call it as, and B3 value is nothing here. So we consider it as a 0. So this is how we can use this chart. We are going to use this chart when we are doing practice experimentation or practice calculation in the Excel sheet. But just before going to that, I thought of showing this one. Now let us go one by one. So here in the variable charts, what are the 3 charts we discussed or we named them? X bar chart. The next one is R chart, and another one is what is that, SD chart or standard deviation chart. Now in those 3 charts we are going one by one. First one is called as X bar. X bar is nothing but a mean chart. We'll discuss what is this X, what is this bar, and all those things. So here roughly the chart will be observed like this. So in the X bar chart, what is the central line? Means X double bar means mean of the mean. X bar means mean. Bar, I mean to say this is X. If I draw one line above the top of that one, it is called bar. If I draw 2 lines, I will be calling it as X double bar. So if I draw 1 bar only, means it is nothing but mean. If I draw another line, means I am doing mean of the means. There are so many samples. For each sample 4 tablets are there. For 4 tablets you will get 4 readings. For those 4 readings you can calculate the mean, that is called as X bar, and assume that sample number is 1, it means called as X1 bar. So at 8 a.m. I have taken a sample, I am naming it as X1 sample, that means 8 a.m. sample, and I have taken 4 tablets, I got 4 readings, I have calculated the mean of those 4 readings, and now what is the name we can give for that mean? X1 bar. Assume at 9 a.m. I have taken another sample. I am naming that sample as X2, and I have taken 4 tablets again. I got 4 readings of weight or diameter or disintegration. For those 4 readings, again I calculated the average or mean. Now I can call it as X2 bar. Like that, if I assume I have taken 6 samples, so X1 bar, X2 bar, X3 bar, like that up to X6 bar. So for every time point, for every sample point, I have a mean value. Now, if I do means of all these means from X1 bar to X6 bar, now I call it as X double bar. So mean of all the sample means is called as X double bar, and I call it as the central line. I call it as the central line X double bar. Fine. Now Based on these X double var, I will be calculating the upper control limit called as UCL. I will be calculating the lower control limit LCL. So we will be knowing how to calculate. But just I thought of showing this graph, what we are going to establish at the end of this X bar chart discussion. So on X-axis, they will be taking the sample size, sample number, or time, or day, or year, or month, or subgroup number. You can name anything. On the Y-axis, you can take the mean value of weight, mean of disintegration time, mean of diameter, mean of marks, mean of salary, something. It is mean of certain characteristic result. So this is how an X bar chart will be developed. So if all the individual values of that particular sample are within this upper control limit and lower control limit, we can say the process or the particular procedure is under control. So as you can see from this graph, all these values, if you observe, no value has crossed the UCL or LCL. Hence, we can confidently say the process is going absolutely fine. So you can relax and continue the process. This is how X bar chart is helping us. Assume that at 6th sample, this value crossed the UCL by having a value here. Then it is giving a caution. You have crossed the limit, upper control limit. The tablet weight has gone to a value more than the expected limit of upper level. Tolerance is more than the upper control limit. Then it is an indication of variation because of some assignable reason. So whatever the change you observe here, it is having some reason. So maybe punchy has some problem, or the speed has some problem, or the power supply has some problem. The granules may be not filling properly into the die cavity, or maybe filling excess. That's why more weight came. So some assignable reason is there. Maybe the operator is not efficient. He is unable to perform the job properly. So immediately you have to identify the assignable reason, solve that problem, and continue the process. This is how X bar chart is helping us. Now we understood the use or benefit to some extent. Now we will see how to draw this X bar chart from the data. So this is again a repetition. I can say X bar chart talks about central tendencies. R bar chart talks about dispersion or variations. As I already told you, R chart, or that means range chart, we may not call it as R bar chart, it is R chart. R chart is suitable to get the dispersion or against observation only when the sample size is small. If the sample size is big, in order to check the dispersion or deviation, standard deviation chart is good. Keep that point in your mind. Now a system, so please remember X chart and R chart, or X chart and S chart, standard deviation chart, as you can see in the flow chart, big flow chart, they are in combination. There is no X chart separately. It is not possible to draw only X chart in order to get a meaningful decision. You can draw, but if it is said to be a wrong assumption, or against a wrong decision. So along with X chart, you are supposed to draw either R chart or S chart. Y means, as I will say Y, but before that, R chart is drawn when sample size is less than 10. And S chart is drawn along with X bar chart when the sample size is more than 10, or it may be something bigger, large size sample. So then here, what is the possibility means, there are situations where central tendency is said to be passed by the X bar chart, but variation or dispersion may be unacceptable. It may fail, or there may be some cases where dispersion will be passed, but central tendency may fail. So for that, instead of trying to understand these English sentences, let me show you one diagram here. So just don't worry about this. So just to see that I am writing mean and mean. If you draw this normal distribution curve, here what is the mean value you observe? 16. What is the lower value you observe? 15.8. Maximum value is 16.2. So in this case, what you are able to observe, mean is 16 and range is 15.8 to 16.2. That means 0.4. 0.4. Fine. So here mean is good. Range is 4.4. Okay. Come to this chart. Here mean is disturbed. The mean value is 15.9. What about range? It is from 15.7 to 16.1. Again, range is same. Please understand, 0.4. Range is same. Here also range is 0.4. So between these two data, range is saying for 0.4. If you draw only range chart, you feel like both are same. Both data are same. Maybe this experiment is in India and this experiment is in some America, we feel like both are same data, very good, excellent. But if you observe the mean value, is the mean same value? No, here in the first data it is 16, in the second data it is 15.9. So what it is indicating? X bar chart is failing. Mean chart is saying there is a out of control, whereas range chart is saying all data are within UCL and LCL. So if you draw only range chart, you give report as pass. But along with range chart, if you draw mean chart also, it is saying that range wise it is good, mean wise it is there is some discrepancy. So then you will have an idea, no, the process is not under control. Mean chart is saying, it is trying to give you some hint. The production people should guess that hint and immediately stop the process, because only one chart has given positive symbol, whereas mean chart has given a negative symbol. So this is the importance of mean chart, where range is passing, mean is failing. Now let us take the vice versa case. Here mean is 16, here also mean is 16. Average values are same, but the dispersions, if you can observe, this is having narrow range, but this is having a broader range. So in this case of study, the mean chart will pass, mean chart will favor you, whereas range chart will not favor you. It is saying the process is out of control, whereas mean chart is saying process is in control. So this is how the both combination of mean chart and range chart are helping us to identify the assignable variation. If you depend only on one chart, there is every chance you can give or you can take a wrong decision, feeling that either the process is good or either the process is bad. That's why a combination of charts application is important. If the data or if the sample size is small, it's a combination of X bar chart and R chart. If the sample size is big, it is a combination of X bar chart and S chart. So along with mean chart, you should have one dispersion chart, either range chart or standard deviation chart. This is how you should remember, not only here, anyway, if you count any marks or percentages of your students also, this is very important criteria. Just by knowing mean value, you should not take a decision. Now let me explain how to calculate this mean chart or how to do this mean chart. So instead of going into the steps in detail, let me show one table here that will give you brief idea. Assume you have taken 4 samples at 8 a.m., 9 a.m., 10 a.m. So anything you can say, day 1, day 2, day 3, or something in mission 1, mission 2, mission 3, mission 4, or operator 1, operator 2. You are trying to compare how the performance is across the procedures or in the process. Like that, you can use this chart for multiple applications. Assume that you have taken 5 tablets. Assume that you have taken how many tablets? 5 tablets at 8 a.m., 9 a.m., 10 a.m., 11 a.m. So and assume that you are trying to check its weight. Let it be weight and its unit is some milligrams or something. Okay, at sample 1, you have taken 4 tablets, 4 individual weights you have noted, and you have calculated the mean, and hence I can call it as X bar. As I already told you, it is X1 bar, simply I can say, because it is sample number X1. For X2, you have again calculated mean from the individual 4 readings. So how we will get the mean means, we will be doing summation plus of all these values divided by sample size. How many tablets? 5. So 98 plus 97 plus of all these readings divided by 5 will give you this data, and I can call this one as X2 bar. This value 98.8 as X2 bar. Same way X3 bar. Same way X4 bar. Now all the 4 samples mean values are ready. Mean values are ready. Now what I have to do? X double bar. How to get the X double bar? Do summation of all these 4 means. 100.6 plus 98.8 plus 100.8 plus 101.2 divided by how many mean values you are handling here? 4. So this summation value divided by 4 will give you the mean of means. So I can call this as mean of means X double bar, and this is nothing but called as the our central line. This is nothing but called as the central line. Now how to get the upper control limit and lower control limit means, just observe here this factor X double bar plus 3 standard deviations. As you can remember the normal distribution curve, I told 99.73%. data is expected to be within that range if it is following normal distribution profile, and that minus side it is minus 3 sigma, minus 3 standard deviation. So here, in order to get the standard deviation, and which chart you are doing, mean chart, so you have to calculate the standard deviation of means, standard deviation of means. So you already have these 4 means values for all the 4 samples. So do calculation of standard deviation for these 4 mean values. You will be getting some data, some value, let it be 1.06. Then how to do this one? X double bar is equal to how much? 100.35 plus upper limit is how much you are taking? 3 sigma. 3 times of SD of means, 3 into 1.06, let it be 3. 100 plus 3 is equal to almost how much? 103. And the same way, average mean of means, that means 100.35 minus 3 sigma, that means minus 3, roughly around 97. So this is how upper control limit and lower control limit can be determined. Now if you can read these slides or sentences, all those things is easy. Just I don't want you to read the sentences and by heart them. But if the practice of this procedure is known, then obviously all these sentences can be easily remembered. This is
Sir, what is the formula for standard deviation?
Sir, for standard deviation formula is like we will be having sample type for population type. So it is square root of, I think I can say formula directly.
Yes, sir.
It is a square root of, yes, sir. It is a square root of summation of the difference between individual value and the mean values divided by the sample number, sir. A sample size, So I think we can do this one in the Excel sheet, sir. So our perspective is not to focus more about standard deviation. So maybe it's about doubt or checking, I don't know. But we can calculate this SD easily by using Excel sheet. If you want to do manually, it is a different process like 99 minus 100.6 whole square, 99.100.6 whole square, 100 minus 100.6 whole square, and whatever those 5 values you will get, you do summation of those whole square values further. So I can write like here otherwise. So xi minus x bar. So just I am doing with mouse, that's why I am unable to draw properly. Whole square divided by n. If it is a population, if it is a sample means it is n minus 1. So manually we can do, sir, no problem. And today we will practice through Excel sheets, sir. So if I go into all these equations, means the time may not permit me to complete these charts. That's why I am saying simply standard deviation, believing that participants may be knowing, or you may work out that one later part also. Thanks for giving a good question. So next one is, so here I want to showcase you a few things. I have confused a lot when I am preparing for this topic long back. A few years back, I started teaching this one to PG, UG students. Almost I am teaching this one for the last 8 to 9 years like that. So whenever I am studying or when I am preparing, I got so many doubts, and I used to interact with maths teachers of engineering colleges and all those things, because same way like how the friend asked me about SD formula, I thought of digging into deeper levels. So finally I got some clarifications. So some books are giving some formulas, some other books are giving in different way. So I thought of clarifying all those things. So today what I try to say present is, so the essence of all those observations. So please consider this way of representation as model 1. Just remember this one as model 1. So whatever may be the model, central line is same, x double bar means calculating individual means and calculating the mean of means. So x double bar central line is same, whatever may be the model. But this mean chart can be drawn by following 3 models. Assume like that, 3 or 4 models also. I will be touching 3 models in order to avoid disturbances, because sometimes if the sample size is more, not only standard deviation, like our friend asked, we can go for standard error mean also, where again we have to divide with square root n. So to avoid all these confusions, let me simplify this task, because so many students and teachers may also be there, and teachers like that. So if already what I can say, teachers with good knowledge are there, happy, they may give me some corrections, I will follow. That's a happy thing. So now let us consider it as there are 3 models. This is model 1. In model 1, what we have done, we have used x double bar plus 3 sigma strategy, x double bar minus 3 sigma strategy to calculate UCL and LCL. So if I ask what is the model 1 for mean chart, means you can speak out, sir, in mean chart model 1 UCL is equal to x double bar plus 3 sigma, LCL is equal to x double bar minus 3 sigma. That's what I am expecting from you. These symbols, you don't worry, Z is nothing but the number of standard deviations. Sometimes you can go with 2 also. They are called as warning limits. So I will explain that one in the chart. And the delta, the sigma subscript x bar is nothing but SD of means. Nothing but I used a simple symbol like sigma to avoid confusion. No need to worry. So now this is model 1 I am saying. Now I want to talk about model 2 in order to draw the mean chart, which is based on R bar, So model 1 is based on standard deviation. Please keep that point in mind. Model 2 is based on R bar value to get the UCLs and LCLs. I don't read these sentences. They are just for your reference later. I will go with the practical procedures only. I will try to explain by own so that you can understand better. So central line, as I told, it is same. It is not disturbed. What is changing? The way of calculation of UCL and LCL are changing. In the model 1, LCL and UCL are calculated from 3 sigma. In the model 2, it was changed. X double bar position is same. Plus and minus are same. But after plus, it was changed to A2R bar. And after minus, it was changed to A2R bar. Whereas in earlier case, it is 3 sigma. So it is a method based on standard deviation of means. Now it is a method based on range. It is a mean range, not even range also, because bar is there means mean. So mean of the ranges, that value we want to calculate. So that means one more column in this table. We want to draw two more columns. One column is for range, another column is for R bar. We will be doing that in the later part of practice. So A2, as I already told to you and shown you one big table, I have cropped the table and presented only small way. So here, what is the sample size? Anybody please speak out by seeing this table. What is the sample size? N is equal to, is it possible? Shall I get answer from anyone? N is equal to?
4, sir.
Sorry, N is equal to, how many tablets are taken in a sample? Total 5 tablets are taken. N is equal to 5. Here N is equal to 5. This, excellent. The sample number K, this is K. I am not asking K. This is K. This K is useful when you are calculating X double bar. Doing summation of these 4 divided by 4. At that time it is useful. But I am asking sample size means how many tablets are taken, how many bottles are taken. So here A2 value, this is A2 column with a sample size of N is equal to 5 you are saying. Then does anybody speak out what is the A2 value at sample size 5 from this table? If N is equal to 5, A2 will be
0.577.
0.577.
excellent. Very good. 0.577, like that we pronounce. So A2 is obtained from table, statistical table, readily available, readily available because of N value. We know N value. And R1 we can obtain from the data. R1 is nothing but range and mean of that range. I will explain how to calculate that. To avoid confusion, assume that we are able to calculate R bar from the data. We are able to get the A2 value from the statistical table. So 0.5777 into, assume R1 has some value like 0.6, both you multiply, do the summation of that value to the X bar, do the subtraction of that value from the X bar to get UCL and LCL. So this is model number 2. So model number 1, we used 3 times of standard deviation as UCL and LCL limits calculation. In model number 2, we used A2 R bar summation, A2 R bar subtraction to get UCL and LCL. Both are to develop the mean chart only. Okay, let me talk about the third model, model number 3. Again, mean chart only we are working for, but here we are going to use the data of S bar chart. Sorry, S bar value. So we are using S bar. Whenever you use S bar, here the factor has changed. Consider this one as constant factor, control constant factor, data available from statistics tables based on the sample size. Like that you can write in your exam, or you can say to our student. So A3, A2, D1, D2, D3, some numbers, some numerical, some alphabets with some subscript of number. So they are nothing but constant factors. They are useful in order to correct the data obtained from either R1 or R bar or S bar, like that. So now this model 3, in order to develop mean chart, the central line is same, but the UCL and LCL calculations are slightly changed. A3 S bar minus A3 S bar. A3 is obtained from this data, so sample size is 5. A3 value is how much? 1.427, readily available from the table. What else we need to calculate? S bar. We just want to calculate the S bar. That means mean of the standard deviations. Mean of what I mean to say? S means standard deviation. I kept a bar means mean of standard deviations. That means I will just go to the previous. So for this first sample, calculate the standard deviation. It is S1. Calculate the standard deviation of second sample. Calculate the standard deviation of third sample. Calculate the standard deviation of fourth sample. So total how many standard deviations we will have? 4 standard deviations. For those 4 standard deviations, calculate the mean. That mean value is nothing but called as S bar. So from the table, we are able to get this S bar value easily. Multiply that S bar value with this 1.427. Do summation, you will get the UCL. Do subtraction, you will get the LCL. So this is the third model, which is based on S bar. So does anybody please speak out if I ask some questions like model 1 of mean chart depends on sigma. So is it right or wrong? Model 1 is depending on sigma, standard deviation value.
Yes, sir. Yes, sir.
Very good. Model 2 is depending on mean range value, R bar. Model 3 is depending on S bar. So I hope you got an idea. Now you will don't have any confusion if you read any textbook how they are presenting. Don't worry. Some person may talk about only model 2, but you should remember our today's discussion. Oh, okay, that book is talking about only one model, but we are good enough with 3 models. So okay, fine, that's fine. But don't worry that this formula may be wrong, that formula may be wrong. All are correct only. All are trying to give the final decision making process or final decision making chance to the operator. So now let me talk about range chart briefly, because already we completed this, but just let me give, then we will go to the practice session within short time, because we are running out of time. Because I spend more time for mean chart, because if that is clear, remaining charts are very easy to crack. So range is commonly used in SQC to study the dispersion or variation, particularly when sample size is very small, in the range of 2 to 10. That's good. If the range is more, or sorry, if the sample size is more, R chart may not give better understanding. At that time, we have to go for standard deviation. That point I think I have repeated 3 times, 4 times up to now. So then how to draw the range chart means, for each sample number, that means whatever the sample, one sample we have taken, in each case you have taken 5 tablets. For all those 5 tablets, you calculate the range. What is range? Maximum value minus minimum value in that observation. And for the sample number 2, again you have 5 readings. So maximum value minus minimum value. So what is the maximum value of this? 103. Minimum value is 99. 103 minus 99 is R1. In this case, 100 is maximum, 97 is minimum. R2. Here 102 is maximum, 100 is minimum, R3. So we are able to get R1, R2, R3 up to RK. How many samples are there? Those many R's are available. If you do summation of all these values divided by K, sample number, you will get the R bar. That means mean. That you are just doing summation and dividing with number means it is nothing but average or mean calculation. As I am doing mean, I have right to keep the bar on its head, R bar. So if you do these 2 steps, that is enough with R chart. You are almost done. Now the formula is whatever that R bar you calculated, it is called as central line. And what is the method we can use means same, R bar plus 3 sigma, R bar minus 3 sigma. That means same standard deviation from the first table you can use, and this is possible. Now going to the model number 2 and model number 3. Here also 3 models are there. First model is based on standard deviation. Second model is also based on standard deviation if it is known, and you want to use a factor from the chart D2 and D1. Here there is no summation, subtractions. Please consider this difference. only that summations and subtractions of different models is there in mean chart. In range chart alternative models, there is no summation. Here you can see summation is carried over to model 3, model 2. But in range charts, only the starting model has summations and subtractions, but remaining 2 models, they are direct values of UCL and LCL. That's why D2 and D1. Whereas the earlier case, if you can see A3 is same, but summation subtraction difference is there. As here there is no summation subtraction, factors symbols are changed. D2 value, D1 value. So D2, where we can get these D2s or D1s or D3, D4 means from the table. For example, take this D3 of which sample size 5. For sample size 5, D3 value is 0. So lower control limit is 0. It is equal to x-axis bar, and D4 sample size 5 is 2.11. It should be multiplied with the R bar value. So here it all depends on whether sigma is known or not, whether it is from population mean. So we are not going to touch all those things. It will be again a confusion as we have short time. Just remember that for R chart also we have 3 models based on direct standard deviation and R bar. Otherwise, standard deviation and factor chart, R bar and factor chart. So there are some strategies, and this is another popular model we generally use, model 3 and model 1. So let me go to a rough view of this range chart. Like same way, one center line will be the upper control limit, lower control limit. As I told, lower control limit is 0, means in that case it will be touching the x-axis. There will be no difference between x-axis and lower limit. And these are individual R1 value, R2 value, R3 value, R4, R5. This is a different chart, just I thought of showing. That's all. And x-axis, y-axis you can write based on your data. Now let me talk about the S chart, and then we'll go for practice session. So the standard deviation, as I already told, it is able to give better measurement of the dispersion than the range chart, especially when the sample size is around more than 10. This point starting onwards I am repeating. But now let us see how to draw the this S chart. Again, here also 3 sigma limits, all those things can be followed. But here the models that are highly used are like B2 sigma and B1 sigma. Again, there is no summation subtraction process. So strategies are same. Why I am rushing in this slide means we are going to touch this one in the Excel sheet. We can remember in the Excel sheet. So UCL is equal to some formula, LCL some formula. If the standard deviation of that particular process is not known, we can substitute with the sample standard deviation. So if we don't know the process standard deviation, we will go with the sample. So like that, there are some formulas for standard deviation chart also. Now let us have a small practice with the charts. So now I am going to Excel sheet. Now based on that, you will have an understanding how to draw the charts. So don't worry about all these formulas. If you can practice this drawing of X chart, that will give you a better understanding. Okay, so are you able to see my Excel sheet? Anybody can
Yes, sir. Yes, sir.
Okay, assume that I have taken 6 samples, 8 a.m., 9 a.m., 10 a.m., 11, 12, afternoon, 1 o'clock. I kept name some name, and it is K. And I have taken 4 tablets. This is some data, 4 tablets. And I have checked its weight. First tablet 296 mg, 300, 301, 298. So this is the data. It was obtained from your experiment or from your manufacturing process in a multinational company like that you feel. So this yellow color is the table data obtained from the process, and all the remaining things we are supposed to develop. This is for X chart, this is for R chart, and this is for S chart. So I hope you are able to observe some color variations. So I have already done some calculations by using some formulas. I have drawn the X bar chart, I have drawn the R chart. X bar chart is showing that upper limit is this one, lower limit is this one, center line is here. All my, how many samples are there? 6 samples. So all the 6 samples, 8 a.m. sample, 9 a.m. sample, 10, 11, 12, afternoon, 1 o'clock, all samples values, mean values are within the range of UCL and LCL. As I already told to you, I don't depend blindly on only one chart. I will take the help of its friend R chart also, because its size of the sample is just 4 only. So I can use R chart. If the sample size is some 15, 20 number of tablets in each sample, means I have to go for S chart. For easy understanding, I have taken only 4 tablets example. That's why R chart is sufficient. I use the same data for S chart also, just for calculation sake. But if the sample size is more than 10, then we generally prefer S chart. But for now, like this. So assume I have drawn R chart also. It is also saying that this is lower control limit equal to x-axis, and this is upper control limit. All samples, sample 1, 2, 3, 4, 5, 6 or something, all are within the range. So by using these two charts, now what we can say, based on X chart and R chart, the process what is followed in order to prepare the tablets is under control. We can relax and continue the process. Again at afternoon 2 o'clock, I will take the 7th sample, another 4 tablets. Again, I will use this data in order to calculate X chart, R chart. So total 7 samples data. Again, I will draw the chart. Afternoon 3 o'clock, again I will continue. So like that, X bar charts will be continuously going on changing, and it will give us information whether we are going out of control or within control. So shall we start doing this calculation? Anybody can respond?
Yes, sir.
Are you
Yes,
ready
sir.
to
Yes, sir.
understand this?
Yes, sir.
Okay. This
Yes,
is
sir. Please.
solved. This is solved data. Very good. Very good. This is solved data. Now let us go to the unsolved sheet. This is an unsolved sheet. Now we are in the X chart process. So X chart, X bar. How to calculate X bar is equal to, assuming that you know some Excel formulations, is equal to means we are doing some calculation. Average of 4 values, close the bracket, enter. So X bar is obtained by using this tablet 1, tablet 2, tablet 3, tablet 4 weights. We got the average. So just if I drag downwards, it will give you the X bar of first sample, X bar of second sample, X bar of fourth sample. Like that for all the samples, simply I develop the X bar. It is very simple. Then what else I have? See here at the bottom, I to draw. So we got X bar values for each individual sample, X1, X2, X3, X4, X5, X6. And I have drawn, I have calculated, or we have calculated the individual. We have calculated the individual means of samples. This is first sample mean. X bar means what? Or you can write like mean, simply mean. X bar means mean. So mean of first sample, mean of second. How to get the X double bar? Just calculate mean of all these means. How can I write that formula? Is equal to average, open the bracket, select all these 5 values and close the bracket. Just press enter. So this is the mean of all these means. If you can keep cursor here, it will show all these 5 values are considered to calculate the average. And what is the value we got? X double bar. That means mean of means. X double bar means what? Simply it is nothing but your central line. So central line is calculated. And as the central line, just go to the previous sheet. See, as you see, the central line is horizontal. That means same value throughout all the samples. To understand that one, I should get the same value in this column. I can merge this one for our better sake.
Sir.
But, sir.
Sorry for the interruption. So we have 10 minutes
please.
time to complete the session, sir.
Sure, sir. Sure, sir.
Okay, okay, sir. Thank you.
Thank you, sir. Thank you. So in order to get the same value, I will just use the dollar symbols. Maybe you are aware. So I will just use the dollar symbol at all the points. And I will just drag this one, dollars. And I got all same value in order to draw the graph. This is for graph sheet purpose. Then how to get the UCL? Does anyone help me to draw the UCL? In order to draw the UCL, I kept a formula here. If you can see, UCL is equal to first model X double bar. Yes, already I have plus, okay, 3 numerical, okay. I want sigma, standard deviation of what? Standard deviation of mean. So I am pending here. I don't have the standard deviation of means, but we have means, we have the mean values. So are we able to calculate the standard deviation of these means? So simply go to this column, is equal to STDEV, standard deviation, open the bracket, select these means values, close the bracket, select. So I got the standard deviation of means. So this unknown value is also now in my hand. So X double bar is there, 3 is a numerical, sigma is already there. So now in order to get the UCL, what should I do? I will bring here to write the formula easily. So UCL is equal to X double bar. What is X double bar? 300.5. Okay. plus, okay, plus 3 sigma, 3, it is in multiplication, so asterisk symbol. What is, I have to multiply sigma, sigma means what, 1.72. So I will select, or I will, you can type also 1.72. So or you can select this, it will take the number. But as I have to use the same sigma for all the samples, so what is the UCL value? 305.66. Central line is 300, upper control limit is 305. So if you drag this one, it will give you the same value. And what is the lower control limit? Does anyone help me to draw this one? So is equal to x double bar, very good, minus 3 multiplied with standard deviation value 1.72. So just select this and drag. So now are we done with the things or not? I got central line, I got upper control limit, I got lower control limit. Then what else pending? I have to draw a plot. I have to draw the X bar chart. So for that, what are the things I require? I may be requiring sample number. I am drawing for means only. So I want this column. I am pressing the control and I am selecting. I want central line. I want upper control limit. I want lower control limit. So x-axis is sample number. Y-axis is mean value. Central line is this one. Upper control limit is this one. Lower. So all the required things were selected. Now I will go to insert. After insert, I will go to 2D lines. After that, I will go to this factor. So, 1 second. So as I selected a sample number also, I can go here. This one. So it depends on whether you selected the sample number or not. If you select sample number, go to the scattered plot. If you are directly going with only this without sample number, you can go to 2D. Okay, that's fine. Now you have selected it. So the Excel X bar chart is ready. Just select the quick layout and you select the first one. So this one is central line, this one is upper control limit, this one is lower control limit, and these are individual sample means. First sample mean, second sample mean, third sample mean, fourth sample mean. So like by observing this one, are we able to say the process is in control or not? The whole process is said to be in control. This is how we can draw the X chart. This is how we can draw the X chart. X chart. Sorry. Okay, so X chart is done. And then R chart will be there. R chart also we will calculate like max of this data, close the bracket, minus minimum of the same data. Is equal. So it has given the formula will help you to get the R values. So is equal to R bar, that is nothing but mean of all these values. So calculate the mean of these ranges. So we got the mean value. So as I want to have the same data, I will use the dollar symbol. But for now, I am just copy pasting as the time is dragging. Oh, sorry, that was not working. Okay, I will go with the dollar symbols. So it will give you all the same value, dollar. Okay, now just select the same. And here UCL is nothing but we are having a formula already for this D4 value, D4 into R bar, D3 into R bar. D4 value I already got here. So you just use that D4 value multiplied with R bar value. So is equal to drag this in. And here LCL, oh, sorry. Okay, it's changing. So D4 value has to be maintained same value. That's why we are using dollar. So it will be keeping the same. It will give you
so that D3 D4 value will get from the any reference. D3 D4.
This one I will show you. This already we have practiced, you know, that one. Subgroup
Yes,
size
right.
is sample 4 means D4 value is 2.28.
Right, sir, right.
Here 2.282 and D3 value is 0. So we got the same thing. So here we already have all the things. Just select the things. So here 0. Select all the values. Go to insert. Go to 2 lines. Draw the chart. So is the chart in control or out of control? Does anyone speak out? This is lower control limit. This is upper control limit. All the range values are within the upper and lower control. So we can excellent. So all the values. So this is how X chart and R chart are helping us. So I will just go to the slides. So there are some key points as the time is running out. My intention is whatever we have discussed, if you are good enough, that is sufficient to my perspective. So I will just give a brief output about the attribute charts. So in attribute charts, as I told, there will be, is my slide visible? Will someone help me?
Yes, sir. Yes, sir. Yes, sir. It is visible, sir. Please.
Yeah. Thank you. Thank you. Attributes means good or bad, fit or unfit, like that. There are three charts, P and C chart. P chart, here we will calculate the fractions. I will just show you how to calculate the fraction. So this is the formula. This is the formula. Calculation of fractions. That means how many number of defectives are there in all the samples divided the total number of items. So that will give you P bar. This P bar is the central line. So as you know, binomial distribution, P bar is a positive factor, means for success, how many, what is the probability of failure means 1 minus P, because P bar, that means success rate plus failure rate. It's like tossing a coin. Head plus tails chances are 1. So like that, P bar plus 3 into square root of this P bar. Here I have written P, this P bar into 1 minus P bar by N. N is the sample size. So same way like X bar chart, we will calculate P bar plus 3 times of this factor, P bar minus 3 times of this factor. It will give you P chart. So just the P chart will be looking like the same way. And just I will go to NP chart. Here, whatever the P value you got, that should be multiplied with the sample size. That is the only difference. Here in the formula P bar plus 3, but here we will get NP bar plus 3. Here it will become NP into Q. Earlier it is division of N. This will go to upside, N into P into Q. So that is the thing with NP chart. Formulas are similar. Coming to C chart, central line is C bar and upper control limit is C bar plus 3 times of square root of only C bar. Here no N, P, Qs and all those things. And what is this C bar means? How many defects are there total in all the samples? So total number of defects divided by total samples. So that will give you the C bar. So this is how we can calculate this NP bar, and C charts. So as the time is running short and we should not allow our next speaker to wait, that will be a mistake. So just I will be giving you my email ID, drgsnkrao@gmail.com. So those who are having any doubts in drawing the charts or for any further help, I will be available, and I'm very much happy for giving me this opportunity. So maybe because of statistical things and all, I may not be able to handle all the things within this small time. But I hope you are good enough with S chart, mean chart, range chart, and standard deviation charts. Is that fine? Shall I feel like you are getting some idea about mean chart?
Yes, sir. Yes, sir. Yes, sir.
Yeah. Thank you very much.
Thank you very much.
One thing, sir. Kindly send me the PPT, sir. Many number of
sure.
are asking about the.
Sure.
Yeah.
I will do one thing. Not only this PPT, I will share the Excel sheets also, such that they will get a practice session. Still, any doubts means they can contact you or me.
Okay. Yeah. Okay,
yes,
sir. Okay, sir. Thank you.
Okay, sir. So thank you for the sir.
Yeah.
Sir, Koti sir, thank you for your valuable interactive session. We got very good knowledge from your lecturer, and the statistical analysis and the applications of the statistical analysis part is very important in the designing of the experiments. So this is very helpful for our the participants. Hope that so all the participants are satisfied with your presentation. So thank you very much, sir.
Thank you very much.
Sir, as a token of appreciation, we are presenting the e-certificate, sir. Later on, we will send you through the mail, sir.
Thank you very much.
Sir, so this is your e-certificate, sir. Thank you.
Yeah,
thank you very much, sir.
Thank you. Thanks
sir.
to Anand for giving me this valuable opportunity. Yes, sir. Is that okay, sir, with the presentation? Sorry, I thought it is offline. In that way, I prepared, but okay, I try to convey maximum information. I think so. I will share the materials that will be helpful for the participants.
Thank you, sir.
Thank you, Kodeshwara. Thank you, Kodeshwara.
Yeah, thank you, sir. Thank you very much, sir.
Thank you, Kodeshwara. Hospital ki veltana injection ki.
Alage, sir. Thank you, sir. Please take care.
Madam maatlastaru.
Thank you, Ishwar garu. Thank you.
Yeah. Thank you.
Kodeshwara garu.
Yeah. Thank you very much, madam. Yeah, thank you.
Deepa madam, Anita madam, మేడం సార్ ఇంకా రాలేదు మేడం.
సార్ కి 10 minutes ఉందని చెప్పాము, జాయిన్ అవుతారు.
ఓకే 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 మేడం. ఓకే
చిన్ని సార్.
మేడం దీపా మేడం.
ఓకే సార్. సెకండ్ స్పీకర్ ఇంట్రడ్యూస్ చేస్తారు కదా.
ఓకే మేడం. నో
ప్రమోద్.
మేడం సార్ కి ఇంట్రడ్యూస్ ఇచ్చాను, ఒక 2 minutes లో జాయిన్ అవుతున్నాను.
ఓకే ఓకే.
Yes, sir.
మేడం సార్ అడ్మిట్ అయ్యారు మేడం. సార్ వచ్చేసారు మేడం.
ఓకే చిన్ని సార్, ప్రొసీడ్ సార్.
Yes, ma'am. So welcome back to the last session of this today's program.
Sir, good evening, Nagaraj sir. Welcome, sir.
Good evening. How are you?
Fine, sir. Now I'm going for injection, sir, for hospital.
Okay. Take care. She will manage. Okay.
Good afternoon, Nagaraj sir.
Good afternoon.
Good afternoon, sir. Pradeep, sir.
Pradeep.
Sir.
Yes, I'm ready. Shall I start screening the screen?
Sir, sir, can I operate? Otherwise, I will go for a co-host.
No. I wanted to do myself.
Okay, sir. Then I will make you co-host, sir.
Okay.
Sir, before that, we are some kind of introduction, sir.
Fine. Go ahead.
Sir,
go ahead.
Start, sir.
Sir, good afternoon, Nagaraj sir. This is Koteshwar sir.
Koteshwar, Vinnanu, my lecturer, statistics.
Sir, thank you very much.
Anyway, thank you for accepting for preponement.
Thank you, sir.
Because,
sir.
I had an urgent meeting, you know.
Yeah, I came to know, sir. It's my pleasure, sir. No issue. I am ready to.
Yeah. Thank you. We have the reviews from higher education, so we are preparing for it.
Yeah, I can understand, sir. You are a busy guy.
Thank you.
Thank you. Thank you, sir.
Sir, just I make a co-host, sir. Nara,
sir. Yes.
Yeah, sir. Chini, sir, can you start, sir?
Yes.
Good afternoon. Okay, sir. So good afternoon, sir. This is V. Chinni Krishnaya, Associate Professor from Annamacharya College of Pharmacy. It's my immense pleasure to introduce our speaker, Dr. N. Nagaraju, sir, Professor, Sri Padmavati Mahila Vishwavidyalaya, Tirupati. Sir is here with us to deliver a topic on QBD in pharmaceutical formulation development and overview. Sir is presently working as a professor in Sri Padmavati Mahila Vishwavidyalaya, Tirupati. Sir has a total of 8 years of academic experience in the field of pharmaceutical sciences, and Sir has guided 11 PhD scholars in the pharmaceutical sciences. Sir has awarded with a Distinguished Alumna Award for the year 2004 and 5, given by the Manipal College of Pharmaceutical Sciences, Manipal University, Karnataka. And Sir has won Achiever of the Year Award in the year of 2002. And Sir has received various research funding projects like Modrums grant for worth of rupees 14 lakhs from AICT New Delhi. Sir has published various research papers in national and international reputed journals. So with this brief introduction, I'm inviting Dr. N. Nagaraju, sir, to start the session. Welcome, sir. Nagaraju, sir, please welcome, sir.
Nara sir? Nara sir?
Yes,
Yes, sir.
I'm there.
Yes, sir. So I make you a co-host, sir. You can operate your own slide, sir.
Yes, yes.
Yeah.
Sir, you can start now, sir.
Yeah, I'm trying for
Sharing
screen
this.
sharing. One minute. To see the screen, participants.
Yes, sir. Yes, sir. So,
Can you please
yes,
talk
sir.
to the
So,
participants?
so go for enable editing and show the big screen, sir.
1 minute. Yes. Enable editing.
Yes, sir.
Yeah. Yeah.
Yeah, sir. Excellent. Excellent, sir.
Yes, I found around 29 participants, and it's very good that I congratulate at the outset the Annamacharya College of Pharmacy for sanctioning of this faculty development program, and we are, including me, we have got the opportunity to listen to the stalwarts in pharmacy yesterday, Professor Suresh sir and Venkateshwarlu sir, and all those stalwarts where we rarely get opportunity to listen to them. So it has given a great platform to us to interact with such people who are the leaders in pharma profession, and they live by their example. So those are the people are the leaders and visionaries, especially when referred to the Professor Suresh sir's lecture. It was so enlightening, and how we need to what I should say, apply the QBD principles in pharmaceutical education that has to come probably all that. And Professor C.V. Subramaniam and so on. Yesterday, I had little time and I happened to listen to a few lectures also. Today also, I joined 15-20 minutes earlier, and I was happy to listen to the Kodeshwara's statistical approach. And actually, it was a real testing for the participant, especially some assignments and all. Probably this lecture was planned for yesterday first session. That was the after the keynote addresses. I requested Madam Principal and Dwarnath, the coordinator, to put this as the first lecture of mine. This is actually the introductory part. That's why I requested them for the first part of it. And what I should say, fortunately or unfortunately, that could not go like that, and that's why I had to come a reverse way. It must be something repetitions. Uh, the people who are listening across I came to know that people from different parts of India is participating in this um, one week FTP program, and I am sorry if I'm talking too much basics because this was intended to be an introductory launching pad. That's what I requested without going to much details. But anyway, it has come after some few applied parts of it. It is watching Bahubali 2 after, I mean, watching Bahubali 2 without watching Bahubali 1. So probably you need to have, or otherwise, you're seeing the interval part after interval first, and from first to interval part later. So anyway, I'm sorry if I'm too basic and too what I should say, too minimal thing, but my attempt was to, before going to listen to various experts in the industry as well as in the academia and researching, I wanted to put you ready for your what I should say, the concept of it. That's why this is what, as I said, if it is too basic, please ignore. Right. So this is what for last 2 days, you are all of the people are listening are the quality by design, quality, QBD, DOE, statistical methods, and so on. This is a very important aspect nowadays. Not ignore it. But anyway, before going to that, this is my university's entrance, and where I'm be fortunate enough to be part of Sri Padmavati Women's University or Mahila Vishwavidyalaya, where it has completed 25 years of its existence. This is our silver jubilee year. I joined here 15 years back as a professor, and I worked at various capacities in the industry. I mean, in university as well. And now currently I'm officiating as a dean, School of Sciences, as well as a director, University Research and Development. Yeah, this is what I'm very proud that I'm associated with this great university, and where the pharmacy department has got consistently for last 4 years good rank, 46, 46, 47, 47, 46, and last year we have got 42, and it is second in the Andhra Pradesh after the Andhra University, of course. So we are aiming this time, much higher rank. So the NRF rank speaks about the quality of education and research going on in the Institute of Sri Padmavati Mahila Vishwavidyalaya. But anyway, and all our students are girl students from the from Andhra Pradesh, from the state of Andhra Pradesh and Telangana. Still, our institution is on Schedule 10, not divided. It is caters the needs of both Andhra Pradesh and Telangana. And we have around 5,000 students on campus. And we have exclusive engineering college and nursing college. Our pride started of late. And of course, 25 years of existence in Institute of Pharmaceutical Technology. Institute of Pharmaceutical Technology has become older, has been gaining importance, and few staff members already retired, including me. In another 3 years, 50%, 40% of the staff is going to retire. That speaks about the what I should say, the quality of the things what you are going to do, right? So this is only for the people who are not aware of the institution. I wanted to tell them. So before starting the actual part of my talk, as I said, it is very simple and concept oriented, and as I said, it's very basic. I want to just put few slides for your attention, and I added these slides. Now I had a time between 3 to 3:30, and after Dr. Koteshwara's hectic lecture on statistics, and from the morning you had 2 lectures. The catching hold of the final session of any last class of an audience is very difficult, and that too online. So we are not seeing you, and probably you may be seeing us, and we have not got the opportunity to see you. So I thought I will add it up a few slides to make you awake, or say I should say attentive, so that I can take you into the world of QBD, probably starting from the from the basics. So you should be having the 5 important characters to stepping ahead for a stepping ahead in our life and career. So we should have a balance of your credibility, commitment, and see the quality. That's what we are talking about. Going now, quality in product, but quality of us also is very important. Transparency and the trust. So these are all the 5 important characteristic features any person should have to have it to shape up your career. And as most of you people are attending are the young teachers, and the teaching profession, especially in the private sector, is in turmoil due to the pandemic. And many colleges are not able to pay the salaries. Many colleges are paying off salaries, and we don't know what is going to happen in the future. And those people who are in the government sector, like me, and some deemed universities and good colleges like Annamacharya, are getting due recognition, but how long it is going to be very big question mark. So it is very important for us to swim against these tough times ahead, but you should not lose your what you call cool. And those staff members in the mid career are most affected. The people who are have got the career at the end of it, probably 2-3 years, so probably it won't make much difference. But the people who are starters, which don't have much difference, they can always look for a job. But what happened to the people who are 10 years or 10 plus years, where they can go, and where they can fit? So those are all the big question marks in teaching profession. And in spite of that, that the only sector apart from software in India, the teaching profession is doing good. We quickly adopted all the technology, and sitting in my home today now, I am speaking to the people across the whole India. So that is the technology we are using. So whereas the teachers are the first in the line after software to take up the technology and move ahead, I also see many creative teachers are putting their what do you call classes on YouTube, and the YouTube lectures are so informative, and the youngsters are really catching the uh, pulse of it, and they are now at home, don't have any source of education resources are not there. So these are all filling the gaps. So coming to the point, what you require in any thing, these are the five important one. One of the important one is the quality. So whatsoever you do, if you want to do the best of it, you should have a perfect balance of this. So today we will focus on the quality more. So when I was thinking of the quality, and to express the quality, and the perfection is another important thing you require. Having a balance of this is not enough. We need to be Mr. Perfect. That means that's what your quality by design at the end it says. It should be zero defect. That means it should be perfect as per the norms or what you are thinking of. So the best example in India is the ISRO, the missile ISRO, where the missile man, who is called as our Abdul Kalam, is the person who behind this, and the ISRO is doing the excellent and marvelous job in India, in all, especially in the government sector. It's one of the best of its organization, none other than the, I mean, next to America or whatsoever it is going. Some of the things are better than, we are better than America and Russia. So how this is possible? This is because of the constant efforts of all the five characteristic features, what I was telling to you, and also perfection. The perfection is a must. Whatsoever you should do, it should not be hatchpatch. Or it should not be, yes, chalta hai, it's okay, no problem, let's go ahead. What is there? No, it should do perfectly, you should do it. And you should actually, those who are young teachers should have a long career to build in, and where you need to be perfect in planning and so on. I cannot think of example of a perfection other than Bizail. So that's what I thought I can show this slide to you to get us inspired. And what the world nowadays wants is the quality. This picture shows about the quality. What is it? Quality means here, for everything now the quality is required. Before, few decades back, in a consumer section, forget about the pharma section, in a consumer section, anything was all right, it should be cheaper. That was the Indian consumer mentality, where China phones have come, two SIM mobile phones have come, and where it is coming for very throwaway price, and people are purchasing that because they have a craze about the products. And once they come to know it is not a good product, they disbanded and they vanished from the market within no time. Likewise, the Indian consumer society, Indian consumer market have matured enough. Now people are understanding the significance of the quality. So that's what the world needs. Whatsoever you take, it requires we see the quality in the product. You see the quality in the process. We see the quality in whatsoever we do. So how the world is behind the quality? And as Suresh sir was mentioning yesterday, the development part is being takes the leaps and bounds now. As his own words, the corona vaccine has come within a 1 year, where we cannot wait for all the methodologies to complete. And it's the need of the day. So they have come, and the research is still on that. We don't know whether the corona vaccine can be given to the older patients. We don't know. We don't know many things about that, but still we have to use that. So we cannot compromise on the quality. The research is still on. So therefore, it is very important in the endeavors of our this thing. The quality is important. Rather, the quality is been identified as a significant parameter in pharma industry. Also, we cannot take any risk of the quality. We cannot just give some product. and we are not allowed to do also. We have so many regulatory authorities. So what the world needs, I can go on talking about the importance of the quality like this for some more time, or maybe half an hour or so, but all of you know very well. If anyone want to buy something, nowadays I see some of the medical shops, even without knowing, they are asking, sir, we want this product, this company's product. We want this company's product. We want this company's capsules. The question is why? They may not be knowing. They say mainly it is doctor said, but basically it is after that doctor said, it is going to be their experience that that particular company product is meeting all the requirements. Now the generic competition has come. Now we try telling them the generics are equally quality products as that of the things what is going to be. But finally, what it requires is going to be a quality of the product, what it is going to be. Producing a quality product is difficult. Producing something which is okay is very easier. So therefore, all the efforts what we need to keep in bring out the quality product is been well established and well regulated, which is all pharma operations are very well regulated. We need to answer the what I should say, licensing authorities. And what is going to be you are going to achieve with respect to quality is the togetherness. It is not possible individually to take ahead and take the responsibility of the product, bringing from the raw material to the final product. It is not a single step product where everything can be automated. We require a lot of inputs from pilot plant department. First of all, we require a lot of inputs from R&D, pilot plant, scale up, and then production unit. And so many stages are there. So many people are intervened in this. So many people are interwoven. That's what somebody says. The quality is interwoven in the product. Quality and the product cannot be looked apart. So therefore, it is a teamwork. It is not that okay, X will do, I will sleep. No, it is not going to be. That's why the teamwork, the we is very important word, where it is significantly what I should say as becoming what is important crucial step in bringing out the quality product. And of course, that's what they are doing now. For teachers, it's very difficult to spend without talking for more because we are used to talk continuously for a long time. But that is our profession. We are doing it. But when you are in an interaction mode, if you are talking less and you have the opportunity to listen to the other person more, therefore you are increasing your perception about the other person. If we are talking more, we have less time given to the other person. It is very difficult to assess the other person. So therefore, apart from your profession, if you have to understand the better, this is what you need to do. You need to talk less and listen more and act accordingly with 5 principles. Yeah. So with this few words of mine, let me move to the concept. As I said in my introductory thing, I am going to basic, and if at all if you find it is repetitive, please ignore. So what is actually the quality means? That's what from since yesterday you have been dumped with these words till the end of this week. You have different varieties of quality definitions from different perceptions and different authors, different maybe as per the FDA, you have a different definitions and so on, but all of them in their own way, they are correct. So the quality is basically the fitness for its use. Fitness is a very general definition. Fitness for intended use. Whatsoever you are going to use. Say you want a product, say for example, a TV to your house. You want to buy the quality TV. So what do you mean for quality TV? You should have quality picture, quality sound. You have quality in everything what you are going to watch. Sharpness, whatsoever you are going to have. What for it is used? It is used to view the TV programs. So for the use, that should be fit. The fitness for the intended use. Likewise, if we are talking about quality pharmaceutical product, and that should be fit to be used, which are to be recommended by the what I should say, the drug control respective authorities having the minimum requirements. So that's what the pharmaceutical quality means. People say it is a as per the few articles, product free of contamination and reproducibly delivers the therapeutic benefit. So it is not going to be, if I take in a batch of 1 lakh tablet, one tablet will behave a different way and another tablet behave in a different way, all that. So that's what Professor Venkateswara sir was mentioning. So we are talking about the, he was giving example about the dissolution. So when it comes to design space, I will tell you what is it. So in the dissolution, we are checking only a particular batch. So that means we are implying that particular batch, the results to the whole batch of compound. So 1 lakh tablet is there. We are taking only sample of it, N sample. So what N sample shows, that attributes you are giving to total batch. So how far it is correct? So that was a big question mark. But anyway, it should be free of contamination, and the product should deliver reproducibly the benefit, therapeutic benefit, as promised on the label to the consumer. So the labeling quantity, what you are going to, then we see the product has got the quality. Then question comes, is there any test for evaluation of the quality? Yes. If you want to evaluate a student, we give examination. It may be internal assessment or assignments or the interaction or Viva OC or some other similar tests or other things where to assess the quality, continuously monitor the performance. Likewise, the quality will be evaluated both by in vitro and in vivo performance. The in vitro performance of the product will give us the basic idea how it is going to behave in vivo. So, but both in vitro and in vivo performance need to be evaluated, and that need to be within the limits of whatsoever you have fixed. And merely if the next question comes, Professor Venkateswara sir was mentioning, if I remember this point, if you find a particular student is not up to the mark, what you will do? The student will fail, will not get the marks, requisite marks to pass. The student will fail. So in this system, the failing of the student is okay. But in an industry where so much of money, huge money and time and materials is invested, if the batch is failed, imagine how much loss to the company. So therefore, we are not able to take the risk of the failing the batch. So we have to have, by adopting the procedures and methodologies by which we are going to assure the product at the end automatically meets the requirement. So I still remember when I was a graduate student between 1980 and 84 in Manipal. So we used to have in pharmaceutics only quality control tests, right? Then when we move on to the M-Pharm, and subsequently 84 to 86, we got introduced the concept of quality assurance. And and we very well assimilated the link between the quality control and quality assurance. Then when I became a young teacher, and the concept of what I should say, this the QBD, and QBD has started in 2015. But anyway, the quality assurance and further automation has come into the thing. So we have to go ahead with the time and see how this is going to be perceived and how this is going to be understood. And why, as a teachers, we want this knowledge for us is to make the student, even though it's only in pharmaceutics and part of the pharmaceutical analysis, the QBD has become only a part of it, of a chapter. Probably there should be, I strongly feel that we should have a diploma course or certificate course on QBD or different aspects of QBD, and also an MS program, like how other people are 1-year programs can be done on this particular platform. And that particular ideas are possible in case of once the NEP, National Education Policy 2020 is being implemented in full-fledged in coming years. There is a flexibility of the curriculum is there, where the universities and colleges can go in that way. Probably we may not see that that particular change. Probably we may kick the bucket before that. But anyway, so these are the things, changes are happening, and the teachers should be equipped with the latest things, and don't confine to yourself to only the syllabus and the textbook. And you are also listen to our Suresh sir. He was telling B.Pharm syllabus is going to change. So you prepare for the incorporation of these new concepts in the curriculum. So where we need to be apprised of that. The basic objective of ACT or UGC to give, sponsor and encourage the young faculty to take up the FDB courses is that get acquainted with the latest things happening around you and see how you are going to amalgamate in this particular system. So you need to be amalgamate, and you should not you should not be stagnant. If you are stagnant, you are not required by any people. So when you are changing only, your my professor is to tell on those days itself, what is permanent? Only change is permanent. Please be ready for changes and quickly get adjusted to the changes around you and move ahead in the stream. So coming back to the quality evaluation, we have the sets of in vitro and in vivo test, which is going to check the performance of the product, which is going to be an indication of the quality of a product. But that is not enough. Then what is Q added here? So BD is added here. So the design is added here. So the design. So we have the design. I remember here designer babies. Yeah, future is there already in American advanced countries. We can design the baby. What you want in the baby, the color, skin of color, and eyes color, and intellectual IQ levels, and how the child nose look like. All the designer babies are coming, and already few trials has been going on. Something like that. You have to design a product which is having the expected or predetermined performance, and therefore we have no way that failing. Say, for example, if you think of a student, say, for example, higher education, NIPA, say, for example, NIPA, a student passing generally NIPA, what we see? We see NIPA student, so therefore quality is there. A student passing from IIT, yeah, quality is designed. So therefore, it is important to all organizations, including government universities and private universities and higher education centers in the education. That's what Professor Suresh sir was mentioning. The quality has to be designed in such a way that the student who is passing out from that particular curriculum, from that particular organization, automatically qualifies. And he or she need not face any entrance test, screening test, and interview test, all those things. There are many cases when I was in the selection committee of various universities and other boards. We see the students from a few particular group of the institutions definitely are much ahead than that of the same syllabus studied by the some other institutions. So what is the difference? When you introspect ourselves, it is not only the student, it is not only the staff, it is the system, what is being developed, and how many people are going to fit into the system will come. And again, you see, I give an example of here, IITs, few IIT people in the first year itself, few people, maybe 1% of the people will leave or will commit suicide. When you see the recently paper, the first year student of some Andhra person only, that boy has committed suicide. So why it is so? Because not able to come up to the standard or the quality standard has been fixed by that particular organization. So therefore, a lot of pressure. So that type of things, pressure need to be handled in a psychological way. The student has taken extreme way. So the point here is it an education or it is in a product? Whatever the predefined qualities you want to have, you need to design in such a way that the stages in which the product is being coming out of various processes automatically possess that particular performance. It is not that we need to alter something. So it is quality by design assures the in vitro a predetermined in vitro product performance. So again, I will take for a convenience sake, I take the example of Venkateshwara sir. He is talking about the dissolution. You are expecting a dissolution, 90% of dissolution in first 30 minutes. That is it. That is a requirement, your quality requirement. So you need to design a product and come out of the formulation in such a way that you require use the ingredients where 30% or say 90% is released in 30 minutes. And he was also giving the design space. I'll come to that later. I can give another examples, but I thought the same examples will be it will be good for you to go ahead and without with a more understanding. So and these basic in vitro performance test or say product in vitro test what you have done in vitro performance product performance assured, this will definitely followed by in vivo, confirmed by in vivo product performance. So when you design a product in such a way that to meet the in vitro product performance expectations, further followed by in vivo product performance thing, then we say that product is having the quality. Therefore, here quality by design is related to product performance. The product performance has been decided in the beginning, and we will have the objectives 1, 2, 3, 4, 5. Like just how I mentioned, we have a product performance of say 90% should be released in first 30 minutes, or 10% should be released in first 2 hours in case of delayed release, whatsoever it is going to be. That are the objectives what you have met. The product has to be designed to meet that objectives. It is not that do something and test for it. If it's not doing it, try another one. No, it is not going to be. That's why for quality by design, we have the design of experiments, and we have the risk assessment, and we have the such other tools, PAT technology. Therefore, we are going to design the product to have a expected product performance without having any failures at the end, no defects, zero defects. And quality by design usually facilitates the design of the products, what is going to be, what I have just mentioned, and the processes. So it is very important that unit processes are going to be also has to be fixed. And therefore, say for example, to have a product to undergo dissolution, 90% dissolution in 30 minutes, the unit process which is important here is the compression. So how much of the compression force is going to be required? So the compression force is a factor here, which need to be decided before and automatically built into the product, and therefore the product is going to behave in that fashion. And that will enhance finally the product's quality, the more importantly, the efficacy and safety in the interest of the patients. That's what we want. At the end of it, the product should have desirable quality, which has to be approved by the various organizations of what you call approved bodies, regulatory authorities, and these regulatory authorities has to approve, and of course it should meet the efficacy and the safety interest of the patients. So further, as I was time and again was mentioning, the quality should be built in or designed and built during the manufacturing process. That should be not tested at the end. So the quality attributes has to be designed and built in during the process of manufacturing. Each and every stage of manufacturing process, the quality attributes has to be built in. And a product which is poorly designed, say for example, you have gone, I think most of the youngsters in the group usually go for ready-made dresses, and for my size and personality, I seldom get ready-made dress shirt and pant for me. So I'll go for a tailor, a designer tailor to design the product to suit my body. So that is called as a designing. So if I go and buy the things available in the market, probably the outfit will not suit me. Sometimes it is too loose, or sometimes it's too tight and not happy, and so on. So here, what to ensure the quality of my coat or the shirt or the pant, the first what the tailor will do, sir, please come for a trial. So that is one quality attribute. So he has taken that, and he will ask you after come some time and see the where we will see and see whether it is fitting properly or not. Any alterations can be done. So that is called as a designing. So the designing, so now it is, we are sure that the product coming out will be definitely appealing the person, the customer, and customer will go to that particular tailor again and again. So over the period of time, this concept has changed. Now the tailoring, they have their own business, however, but most of the people now, there was a survey in the month I was reading somewhere, it almost 60 to 70% of the youngsters in the age group of 18 to 30 are going for ready-made garments. But anyway, so here, what I want to focus you to is the designing means is that. So the designing should be done in the product developmental level itself. It is not going to be what you call attributed while making the product. A product which is poorly designed have the poor efficacy and poor safety, which leads to the failure by both by the regulatory authorities as well as the what you call the company level itself. And as many of the speakers of yesterday and today might have told you, the same word here, quality will not be improved by merely increasing testing of pharmaceutical products. I want you to underline, bold, and caption golden letters whatsoever it is going to be. Please don't have don't have a myth in our mind where the quality will be improved by testing the pharmaceutical products. Go for many more tests. No, quality cannot be improved by merely increasing the testing of the products. In other words, as the word I just now said, quality must be built into the product. As the product moves on, various process of development, automatically it should pick up that particular quality and move ahead in the next step of the manufacturing. That's how that has to be designed. So the designing is having more significance and importance, and the manufacturing comes the later. And as again, Professor Subramaniam sir, I think he was giving the history of the this QBD, and the FDA has become part of the ICH guidelines of Q8, 9, 10, and 11, whatsoever it is going to be. The FDA has made, this is the starting, where the PAT process analytical technology has been made in 2002, and it's been mandatorily they have made, they had to follow 2013. It is going to be the optional, people won't usually follow, and it is mandatory, please people will try to follow. So this process analytical technology is the first step in the quality by design. And this was the beginning of the journey towards the implementing the quality by design. So the PAT, what I say, we call it as process analytical technology of the process as well as the product understanding is going to be very, very important. So a group, a team is required here to critically evaluate the how we are going to apply the PAT both in process and product understanding. Then fix out the what is you are going to do. And the risk assessment is always there, that is associated with the product development. What is going to be the risk you are going to face? And more importantly, identifying critical quality attributes and identifying critical process parameters which need to be monitored throughout as a control strategy. So here I would like to focus your understanding the what is going to be the process steps, which is where on which the product quality is depends on, that you need to identify. What is going to be the parameter? Say for example, you want the drying process has to be properly done, and it should not, the granules should not contain more than 2 or 3% of the moisture. So what is the critical process parameter here? The temperature and time of temperature to obtain this, how much you are going to apply. That need to be evaluated. That's what the process critical quality attributes, whatever the steps or the stages where the quality is being affected, and what are the steps or stages where the process is having the effect on that. If that is controlled, probably you are able to get the final product which is going to have a good quality. So this particular picture shows about the raw material subjected to manufacturing process, and you are going to get a product. This is what a regular manufacturing, any manufacturing unit will talk about. So where we are talking about the variables means where there are the different change of this particular variable will have the effect on the quality of the product. Those are critical process parameter, just now I said, adjusted by the measurement of the critical quality attributes. That's why both are related. So the process parameters are going to be adjusted by seeing the quality characteristic features. So then we see the forward is going to be there and feedback is going to be there. Therefore, we have an effective control of the manufacturing process, and therefore we get a product which is having the quality what you are looking for. This is I try to put this table. I'm sorry it is having a poor quality because I directly taken from this particular reference. I didn't try to redo this. I just see one or 2 points from this and compare what is the traditional way and what you are going to do in the quality QBD way. Yeah. So when you talk about the pharma development, where the traditional way, what we are going to do, empirical way, that is by trial and error, doing the experiments and changing the one attribute and adjusting another one, fixing one variable and altering another variable, a very tedious process we are going to do. And whereas in the quality by design approach, we approach a systematic approach where the design space is created here and which is going to take care of multivariate experiments with a proactive to design quality into the product. So the design space is very important here. We need to have a workable space for the development of the product where the product can have in a particular range of expression of the quality you can have. Then yesterday, Venkateshwar sir was mentioning about this when I was listening to the lecture. The manufacturing process. Traditional way is we have the manufacturing production sheet from the pilot plant department or the R&D, where you are not allowed to alter anything. We just read the whatsoever the formulation ingredients and follow the process as per the SOP. But whereas in QBD, we have got the flexibility within the design space that can be more accurate. And coming to the process controls, most of the process controls are offline. So, and quality testing only, it is not inbuilt. Whereas here we have online. Again, I take the example of mixing, where sir was mentioning, that can be, I think, can be estimated. The mixing by the FTIR attached instrumentation, we will be able to find out what is the mixing quality and where the fat is going to be used, monitored process analytical thing, where the online feedback we are going to get, and accordingly we can design space, we can work and bring a good process controls. When you talk about the product specifications, and in traditional methods, the product specifications are primary for quality control based batch data. So for an effective quality, the specifications are after the product is manufactured, you are going to test for it. Yeah. So that is what the traditional method. Whereas in QBD method, it is going to be the part of the overall control strategy based on the desired product performance and the predictability. Whereas the life cycle management and control strategy is also a significantly different from traditional way to that of the QBD way. In traditional way, the control strategy is in-process control checks mainly focused on quality by testing, whereas in QBD, the same is the risk assessment. That's what I was talking to you many times. Risk-based monitoring and PAT-based real-time testing methodologies. So that is going to be more applicable, and we'll be able to get the better product, what I should say, quality at the end of it. And many of the speakers yesterday also spoke about the life cycle management. I have a next slide about that, how QBD is going to influence the life cycle. The more reactive actions as well as the post-approval changes are required for the life cycle management in a traditional way. Whereas in continual improvement, the design space is based on the feedback of feed process forward that is going to be taken care into. So likewise, the advantages and QBD over the traditional ways has got a very long way to understand the process of implementing the quality in the product. And I'm coming to the definition of 1 minute. It has become so dark. I will switch on the light and come back. Yeah, I hope it is better now. Yeah, the US FDA defined quality by design as this is also many people have, including TV Narayana, was reading this. We cannot change this. The definitions, all definitions are as per the uh, respect to other authorities where we cannot change it, right? So it is a systematic approach to development that begins with the predefined objectives. So the objectives, we cannot just enter the formulation development, but we should have a predefined objectives before going for manufacturing, and which emphasizes the product and process understanding. What is actually the product and how the process here we are making into, and what type of controls we are going to execute on that, which should be understood based on the sound, what I should say, the science and quality risk management. This is what the US FDA defines the QBD as this one. So coming to the tools of QBD, we have various ways by which the QBD is implemented. So the QBD is implemented. These are all the various ways by which the QBD can be applied. That is a design of experiments. These are the way by which you are going to improve and optimization, what you call full factorial design and partial factorial design and plug and permanent designs, and the statistical designs and other such optimization parameters. Probably in due course of your program, few of the speakers will touch on this also to make acquainted to you about what are the various software and concept involved in the design of experiments, and the risk assessment methodology, and more importantly, the first step is a process analytical technology. These are all the some of the tools which are the QBD process. Oh yeah, this was the picture I was about to talk to you. How the QBD is interlinked or improved or dependent on the various stages in the drug development process, product development process. So it is going to be very, it can be applied the first and foremost thing, quality target product profile, QTPP. That's what yesterday Subramanian Swara was mentioning about this, and all other speakers were talking about this. The first step, quality target product profile. We need to come out of a product profile where what type of quality you want to have to possess in your product, where based on QBD. Critical quality attributes. That means the factors on which your quality is going to be based on. If you recollect the picture shown here to you, the product and manufacturing process and the final product. So the quality attributes which will be measured by the critical critical process parameters, which can be obtained by critical quality attributes that need to be done. Yeah. Next is going to be linked with the material attributes and product profile to critical quality attributes and risk management. We need to link all these parameters using the QBD principles, and thereby establish a design space. The design space is important. In trial and error method, we will not have any design space. Whereas here, that's why I said in the previous slide, the process is a flexible process. The manufacturing process is fixed in traditional one, whereas flexible within the design space. Within the given time, the space, if some range of it, the product can be the manufacturing floor. The manufacturer can use this space and produce the best product. And QBD is effectively used in establishing the controlled strategy. What strategies you need to follow. Then, of course, the life cycle management. So this is the 6 important ways or by which the QBD is affected or implemented. So what are the objectives? So the objectives of the QBD, as probably I'm coming to the summarization of it, and see the quality target product profile. The quality target profile, the quality target profile is one.
Sir? Sir, Nara, sir? Nara, sir?
Are you able to listen to me?
Yeah, sir. Right now. Okay, sir.
Okay, okay.
But your picture,
So,
fine, fine, fine. Okay, sir. Okay,
yeah,
sir.
yeah. So the quality target product profile need to be identifies what is the critical quality attributes. That means, say for example, I want the product to be having the release profile as a control release. It should have only the release the product only 0 release in first 2 hours, and then 3 hours, and afterwards it is going to release another 1 hour or so the whole amount. So this is the target. So likewise, what is going to be the quality targets, you can fix it, and those quality target product profile targets identifies the critical quality attributes. So what is a quality attribute identified to the not to have the resolution in the first 3 hours? It is the enteric coating. We need to have enteric coating, or say retarding polymer concentration and coating, where we need to have the disintegration, no dissolution and disintegration can be there. So critical quality attributes will be identified by the designing of the quality target product profiles. Likewise, each and every product, you need to identify the product profile, and which further identifies the what is the attributes which is going to be affecting this particular performance. So to understand in the teacher's language, yes, we want in my class of biopharmaceutics, I want all the students to score more than 90%. That is the quality product profile, what I want. So what is a quality attribute here? So I want a profile that 90% of the student, 90% of the students, I want all the students to score 90. What I said, I want the say 50% of the students to score 90% of the marks. So what is the critical quality attribute here? That is different. What is teaching, sincerity of the student, and our assignment, the quality, what do you call, teaching learning process and evaluation methods, which becomes the part of the quality attribute, therefore, to achieve the final product profile. So these are all together make a student to achieve 50% of the students to achieve 90% of the marks. Likewise, each and every product will have a quality target. So these quality target, which in turn identifies what should be the quality attribute which is required for the drug product. So then we get the product design and understanding, including the identification of the material attributes, critical material attributes. So what materials we want? So I always remember my professor's words here, junk in will come junk out. So without the proper quality product raw materials, we may not get the quality product. So we need to start, the starting material itself should be, what I should say, having a good quality. Say for example, you cannot expect end product with zero or say acceptable limits of microorganisms if your raw material is highly contaminated. If it is highly contaminated, if the process what you are following is not enough to remove all the microorganisms, you may not get in the end product which is having the very less microorganisms to qualify the standard. So what is going to be the here the process objective here? We should either intensify the process in such a way that the microorganism load should be reduced, or identify the source of the material where the what is going to be, and talk to the vendor and see the product what you are going to get is going to be having a very low microbial content. So likewise, the designing each and every step need to be understood. So the product design and understanding, including the identification of the critical process parameters. See, if you want a nano emulsion, so what should be the speed with which you need to, uh, what should be the emulsifier you should want, what type of ultrasonicator you are going to. So likewise, for each and every processes, what is to be required has to be understood, and thorough understanding of very important scale up principles. So many of the products may perform very good at the laboratory scale, therefore, and also pilot scale. But if you are making it to a larger scale, it is going to be very, very difficult. In a production scale, they may fail. Again, this itself is a pilot plant scale of technique is itself is a vast subject where we need to have that particular understanding. So if at all you want to have that particular designing, a proper linking of CMA, CPPs, CQs, and the scale-up techniques are essential. So it is going to be in the lot of homework has to be done, a lot of launching work has to be done, a pre-production work. That's what people in the movie theaters, movie directors will tell. I think if at all the movie director Rajamouli, I hope pan-India director he is. So he takes the movie for not less than 3 years. So 1 to 1.5 years, he will only get this identifying the product profile and critical quality attributes and designing and also scaling up. And then once everything is ready, you will go to the manufacturing shoot. So this is what the quality product, what's the quality of the output, what we have of these films. But only problem with him is long time. But anyway, in pharma industry, you cannot afford to have 3 years for the launching of a product. Then your sponsor will tell you get lost. So we need to cannot go for a time which is going to be not realistic, but we need to complete all these processes in a realistic manner. Then the control strategies, which include basically the focus on the specifications for the drug substances, and more importantly, the excipients and also the product. So we need to evolve the specifications for this. As just now mentioned to you, we cannot start with a raw material having a highly contaminated microorganism, expecting a zero microorganism end product. No, we cannot have. So you need to develop an acceptable, what I should say, a control strategy, sit with the vendor and come out with the inspect his manufacturing facility and see how your product can be obtained, raw materials can be obtained, excipients can be obtained with the specifications what you require. Sometimes you require a drug substance specification, the particle size should be within this particular range. So even though the particle size, plays a very important role in the resolution and so on. So it is crucial in some of the critical quality attribute here. The resolution depends on the particle size. So therefore, we need to talk to the vendor how he is going to give us this particular size of this. So therefore, we should have a important a controlled strategy which includes these things. And also, we should discuss about the controls for each step of the manufacturing process. So It cannot be once, we cannot say that once it is started, we cannot stop. No, that should not be. We should have control on each and every process, and the process is going to be designed in such a way where the controls can be easily executed. And again, there should be a scope for a good process capability. And this is what all the speakers are also, what you also see, this continual improvement. So the continual improvement from the existing one is an added advantage in QBD. It is not like the traditional one, is where we see the product is being manufactured as per the production sheet, and we are going to forget about it. Whereas here we are going to manufacture the product in the design space. What is going to be obtained you have got, and that is going to be, there is a chance for improvement, and the improvement need to be the improvement need to be shown, and with the proper risk management. Yeah, so I'm putting up all my discussion for last 1 hour or so in a one slide or so, the particular thing. The transition from reactive to proactive. I have not touched about any statistics. I have not touched about the tools of optimization, DOE, and whatsoever it is going to be. I have not gone into the technicality of it. As I said to you, I want this as a first lecture. Therefore, you have some idea, and go ahead and listen to other people to assimilate. But anyway, no problem. No problem. So the transition from a reactive to proactive approach to achieve right at first time. So you cannot say no problem here. You have a second attempt. You can apply. You can pass in supplementary. That opportunity is there for a student in academics, but in product development, in this thing, we don't have that particular option. It should be right at very first attempt. And of course, it is a risk-based and science-based approach, right? And it is primarily focuses on patient safety and product quality and efficacy. One F is missing here. Sorry for that. And improvement in product and process understanding. And and then improvement in process capability, robustness, consistency in commercial manufacturing. This is very important, and you may do wonders at the laboratory level. When it is coming to commercial production, if it is failing, then we have no such applications. The system is failing. The systematic development, reducing reworking and rejection. This is very, very important. Previously, the traditional approach, we see the reworking and rejections were quite a few, and industries used to lose so much of money and time in reworking process. And usually they terminate the people who are in the quality as well as the production and so on. But that quality by design will avoid these type of things, because we are putting each and every stage a control one. We are understanding what is happening, what is going to come out from each stage. And significant reduction in regulatory oversight post-approval due to the transparent operations. When, as yesterday, the speakers were telling, that, I want to refer again here, if you say that you are prepared, your manufacture or quality by design, so probably the FDA may not look into most of your documents again. Only the superficial and regulatory intervention will not be there because of the transparency in the operations. And driver to business benefits, that is going to be very, very important. And actually, I wanted to give for some case study. I am leaving it for the people. If it would have been come personally, I would have done this case study to you for another half an hour or so. Please see the reference number 5 and 6. Are you able to see? I think you are not able to interact with me. Pramod, they are able to interact with me.
Yes, sir.
Okay. So 5 and 6 are the websites of FDA, where there is a QBD approach for immediate release tablet as well as modified release tablet. So what I want all the participants should do is go back home if you have time, and I'm sorry, you are at home only. If you have time, if you have net speed connection, at least see that what is happening here. And of course, most of it was FDA and ICH guidelines. And this book is very helpful to you, quality by design concepts for ANDA. This book is very helpful. I think I found that this online copy is available. So if that is available, probably I didn't get the short notice, but people are telling, my friends are telling, this online copy is available. If I have that copy in due course of time, I'll share with the Annamacharya College and all the participants can have it.
Thank you, sir.
So with this brief set induction to quality assurance, quality by design, observed quality by design, I thank all of you, each one of you, for your patient listening and as well as the support to me. And again, this particular one I want to read for you. It is none other than Abdul Kalam. Fear. It is very important. What is actually the meanings of these two meanings of the fear? The first meaning is which is negative, forget everything and run. This is escaping. That's what we do in fear. Whereas face everything and raise. This is the actually difficult times what we are going to. The choice is yours. How you are going to take up this, go ahead to come up in your professional and personal life. I once again thank the funding authority as well as the Annamacharya management and the principal and my good friends, Swarnalata, Dr. Swarnalata, principal, and Dr. Dwarkanath Reddy, and other staff members for your excellent support throughout the organization. And I hope I would like to have a feedback of this. Please give the feedback, honest feedback that will help me a lot in designing my future talks. So if any questions are there, you're welcome. And if I know, I will answer. Otherwise, I will find out the answer and let you know. Thank you once again.
Thank you, sir. So thank you for your valuable speech, which has enlightened the knowledge of our participants regarding the concepts of QBD. Thank you very much, sir.
Yeah. Any question answer question section is there? Participants have got any questions? Pramod?
Oh.
Sir, will post it, sir.
Yeah, some chat box is there. Some software is recently used in QBD, especially in industry. Yeah. There are many softwares free as well as the softwares are available. Probably I don't have immediately the information about that. I can share with you the information in due course of time. Immediately I don't have that. Actually, I have one slide about that, a capture slide. But anyway, at present immediately I don't have this. Probably I can try getting it and share it with you. Thank you, Shushama. I think you are from Goa or Maharashtra. Pramod, these people are allowed to talk?
Yes, sir.
Yes, sir. Yes, sir.
Sir, I'm from Delhi.
Instead of chat box, I would like to listen one
I
or
will
two
ask
questions.
post to allow them, sir.
Pardon?
Ask post to unmute. I will ask post to unmute them, sir.
No problem. They will talk. No issues.
Okay.
I'm
Okay.
from Delhi, not from Maharashtra. I am Maharashtrian, but I am from Delhi.
Oh, very good. Where are you working now?
Delhi Pharmaceutical Science and Research University.
Sir.
Yeah, DIPSRU. Yeah.
Okay. Okay. I got my APTI Best Teacher Award from Vice Chancellor, Goyal
Okay.
in Jaipur. I got his photograph with me, and your former registrar, Raman Dang, is my good friend. He is working in the same organization in Bangalore where I was working previously.
Sir, on the same day, same year, I got the Base Research Award. Professor.
Oh, you are there on the stage?
Yeah. I was there.
I remember two from the DIPSR has got the award, no?
Yeah.
Yeah, very nice, very nice.
Yeah. Same here, sir. Same here.
Nice interacting with you. Nice interacting. How do you feel? Is it helpful to you or it's too basic?
No, sir, it is always helpful because we continuously we are not using. So if we are attending such type of seminar, definitely it is going to be refreshing. Because
Okay.
every time we are not applying the QBD, na, so we just forgot
Yeah.
about what are the different steps, and then we always implement. Yes,
Yeah,
sir.
yeah.
It
You
was
got the
very
best researcher award, no? Last
yeah,
time?
CJ
Yeah, I
Shishu.
remember.
Yeah,
Yeah,
CJ Shishu award.
yeah, correct, correct. Nice, nice. Any other questions or the comments or suggestions?
Sir, it sometimes I feel ki it should be a hands-on training. Means full factorial design, or maybe central composite design, or maybe box Venkham design. What type some case study, and everyone should open their screen and then they should operate.
Correct, correct. Usually workshop is like that only.
Yes,
And
sir.
I think Professor Koteshwara is given that type of
Yes, yes,
assignments,
yeah.
no?
Yes,
Yeah,
yes.
yeah, yeah.
Yeah,
Usually we plan
yesterday,
like that only for
yeah,
workshops for the
yesterday,
teachers.
yes, sir,
Yeah,
yesterday only I have written some case study should be there. They asked the suggestion in the
yeah.
form. So
No,
I'm
actually, as I said to know, madam, this lecture was more fundamental and set induction lecture.
yes,
So
yes, sir.
probably I didn't plan.
Yeah,
Actually, I
yeah.
was planning an FDA case study. I wanted to present the case
No,
study,
no, we will go
but
through. We will go
yeah,
through.
that one I didn't do. But otherwise, as you said, for training programs like that, we usually do. But it's well taken, and definitely in future course I try to
Yeah, it
introduce.
takes time, sir. Na? At least one day, full day,
Yeah,
because
yeah,
so
correct,
many queries and all. Na? Because everyone is
correct,
opening the screen. फिर किसी का वो
correct,
open नहीं होता
correct.
है. Then again, they are so many queries are there.
So recently, I have gone on 1 week. University is deputed all the senior faculty to state government one workshop they have conducted. The workshop. So the workshop, most of the sessions were like this. What you are telling, we should be always taking a paper and pen and writing it. On the same day, we have the assignment. On the same day, we have the questions to be posted, and we need to answer that, and we need to, go ahead and all that. And that was really helpful to us. And also one UK training ship. I think you must be your university might have deputed you. That was Bright Space training program from the
AICP.
not it is a
Yeah,
UK.
UKRI. Yeah. I was not there. Yes. Somebody else. I think
UKRI was
Dr.
very helpful.
Yeah.
I was there, and our project proposal has got the best project proposal in the team,
Wow,
and
great.
they have taken as a model.
Oh,
That
great.
also I was enjoying every
So where
Thursday
it was?
2 hours and
Previously it was in
assignment and
Singapore.
working in the night. Yeah.
It was in Singapore.
No, it was online.
Okay, online. Great.
It was online. So it was online. They planned in Delhi, but finally they
Pandemic.
could conduct online.
Okay, great.
Yeah, 3 people from our university was deputed to attend that, especially those who are in helm of affairs. Like I was the dean and one director from the nursing college and one deputy registrar from the university has been appointed. I mean,
Okay,
we 3 attended this, and it was very nice. UKD program was very nice.
Okay. Okay, sir.
Susamaji. Good evening, Susamaji.
Sir, excuse me, a little bit louder. Any other?
Good evening, sir. Good evening, Nagaraj sir. How are
Good
you,
evening.
sir?
Fine. I'm not able to get you. Who is this?
This is Deepa, sir. Dr. Deepa from Annamacharya College.
Oh, Principal Garu. Okay.
No, sir, I'm not. Yeah.
Actually, Susamaji, we plan to have when we plan
please tell me what is the next. Shall we close or ask the participants? And please share, Pramod and Dr. Swarnalata, the feedback. I would like to see the feedback of the participants. Yeah.
Sure, sir. We will send you, sir. We will send you.
Yeah. Shall I now call it a day?
Yeah. 1 second, sir. Deepa, madam.
Yeah, sir. Yeah. Am I audible, sir?
Yes.
Yeah. A very pleasant evening to the respected principal, eminent speakers, Dr. GSM Koteshwara sir, Professor Nagaraj sir, and my dear delegates and colleagues. I, Dr. M. Deepa, on behalf of Annamacharya College of Pharmacy, I'm very fortunate to propose the thanks to a well-known and prominent speakers of today's session, Dr. Jason Kodeshwar sir, for his excellent presentation on statistical quality control. And I extend my thanks to Professor B. Nagaraju sir for outstanding presentation you made on QBD. Your depth of understanding and your ability to explain the topic in such a way made this afternoon session more interesting and memorable. We are much honored to listen to you, sir. I thank today's chairperson, Mr. C. Chinikrishna sir, for handling the session, and my sincere gratitude to Principal Dr. D. Swarnalata garu and Coordinator Dr. P. Dwaraknand Reddy sir, and coordinators Dr. C. Suryaprakash Reddy sir, Dr. N. Raghavendra Naveen, and Mr. Y. Pradeep sir for the technical support and effort for the smooth conductance of this event. Thank you, one and all. Have a wonderful day.
Thank you.
Thank you.
Thank you. Thank you.
Thanks for the
Sir,
opportunity.
so this is your e-certificate. We will send you through the mail, sir.
Okay. Right. Thank you. Nice.
Okay, sir. Thank you, sir.
Nice.
Thank you.
Thank you, sir.
Okay.
Thank you, sir.
Nice. Thank you.
So tomorrow, by means of 10 a.m., the third day sessions will start. We will send you the shares, Zoom link and YouTube link by means of morning or today evening itself. Thank you. Sir.